Good morning, everyone. We will be starting in 2 minutes.
I think you can start, Marty.
Okay, thank you, Kuya JP. Magandang umaga po sa inyong lahat. So, it's a Sunday today and we're very thankful po na kahit Sunday nasamahan niyo po kami dito sa aming web lecture. Again, ako po si Marty Mateo from the Filipino Science Hub, and we will be having our webinar today for the introduction to organic chemistry that will be delivered by, again, Professor Dindi Yu Voils from Louisiana State University. Next slide, please. So, just some house rules. We kindly request you to mute and turn off your video unless you would like to post a question or comment later on after her talk. And please don't record the session because the full video of this event will be uploaded on our YouTube and Facebook channels. Next slide, please. So after the lecture, we will be having an open forum. So there will be a 30-minute Q&A session after the lecture. And please reserve your questions toward the end of the discussion. And you can send your questions via the Zoom chat box if you are in our Zoom channel or via YouTube comment live section on our YouTube channel. Next slide, please. So you will be given a certificate of participation We will just post a Google form link to issue a certificate of participation for this session in the Zoom chat box and the YouTube live comments. You will also see the Google form in the video description in our YouTube channel. And for you to get your certificate, you should be a subscriber of the Filipino Science Hub's official YouTube channel and also Facebook page. That's Filipino Science Hub. Next slide, please. To introduce the Filipino Science Hub, I turn over the floor to Dr. Jeffrey Bungkin. Kuya Jeff?
Okay, thank you, Marty. Magandang umaga po sa inyo lahat. Ako po si Jeffrey Bungkin, ang founder ng Filipino Science Hub. So, bago po tayo magsimula, gusto ko muna pong i-introduce sa inyo para dun po sa mga bagong nagpa-participate dito sa aming mga web events, kung ano ba ang Filipino Science Hub. So, Filipino Science Hub is an organization that we founded back in 2012, and its main objective or its main mission is to promote the cultures of STEM education and research among students and teachers in the Philippines. And as you can actually see, we're composed of a group of Filipino scientists from different parts of the world, working together to deliver, to reach to reach a vision of a STEM or an innovation-driven Philippines. So kami po dito sa Filipino Science Hub, this is actually our ultimate goal. And how can we achieve a technology and innovation-driven Philippines? That is by launching a new generation of Filipino STEM enthusiasts. So gusto po talaga naming ma-encourage ang ating mga estudyante na mag-pursue ng career sa sciences. Gaya po namin na mga STEM practitioners ngayon. I am a Filipino scientist practicing my profession in research here in the US. We do have other members who are based in Europe and also in the Philippines working in different areas. So we do have our team is composed of practitioners of STEM in the areas of commercial manufacturing, in the areas of education, higher education, as well as government or type or government funded research. And so for the question is, paano ba namin may enable or paano ba tayo makakapag-launch ng bagong generation ng STEM enthusiasts from the youth or from our students? There are two different there are two main components to our campaign, and the first of which is to strengthen the STEM fundamentals, amongst Filipino educators. Ang ating pong mga guro, ang ating academic frontliner. So, kung maganda po, kung mataas ang kalidad ng pagkakaintindi nila sa sa STEM courses or sa STEM subject areas, we can expect that the quality of education that our students will acquire from them is also of high quality. So, yun po, one of our priority programs is to empower our STEM educators. But then, in order for you to be able to launch a culture, you don't just settle for a strengthened fundamental understanding of the sciences. Bringing in practical experiences and insights from STEM practitioners, so mainly Filipino scientists and STEM experts and subject matter experts, bringing that community closer to to the educational sector will further enhance yung enthusiasm po at yung interest ng mga bata, kasi kami po mga scientists naman ang magbibigay sa inyo ng real life example. Saan ba napupunta itong mga inaaral natin sa sciences, na ito ba ay base yung bang pagkakaintindi natin ay ililimitahan natin sa libro? Hindi po yun po yung gap na i-fill ng FilSciHub. We are introducing you to modern day Filipino scientists, and we will also try to give you the opportunity to have a peek at the career that they have, the types of opportunities that the students can eventually run into, if they pursue a career in the sciences. So yun po yung dalawang main programs namin. So we do have an education program via FilSciHub Ed, and we do have free research mentorship and training via FilSciHub Research University. Okay, so this is how we view the FilSciHub roadmap. So at the moment po, we have like approximately more or less 30,000 educators following our platform. So if you empower the competencies of our Filipino STEM educators, and imagining the number of students that they're teaching each year and the number of years that they could um, spread out and share the knowledge that we are sharing with them, you can imagine that we can impact the lives of 20 of millions of Filipinos. At yan po yung unti-unti naming i-deliver sa inyo. And for the STEM educators out there, we're just asking you the favor po of helping spread our platform para po mas marami po tayong matulungan. Kung ano man po yung yung mga volunteer activities na ginagawa ng mga kaparehas ko ng mga science practitioners, sana po ay matulungan niyo po kami maipahatid ito sa ating mga estudyante. Lahat po ng aming activities dito sa platform na to ay libre, hindi po kami nagpapabayad. So we're hoping that our STEM educators will also help us to spread this endeavor around, most especially help us reach the students kasi sama-sama po tayo. We divide up the effort and then we multiply the impact. So yun po. And then where can you find us? So Filipino Science Hub is all over at least like 4 different platforms. So we have an official website, www.filscihub.com. We have our Facebook page. We are also on YouTube and we're also on TikTok. So what kind of materials do we roll out? So we come up with webinars, so teaching webinars to strengthen to empower our STEM educators. We also have STEM lectures, that would cater to both teachers and students. Kung ano man po yung pangangailangan ninyo, we're coming up with refresher courses like this one that Dindi is delivering. We also have web tutorials. We have teaching modules and also problem sets. So nandyan po yan sa website natin at sa Facebook page. We also have virtual labs. So we're trying to actually compile virtual activities that you can adapt for teaching specific STEM topics. And then we do web features because like we said, we would like to present the human side of Filipino scientists. So just to encourage everyone can be a scientist. You don't have to be a genius to be one. So ito po yung mga programa namin sa Filipino Science Hub na aming inihahatid sa inyo. And towards the end po of this lecture, we will also talk about programs that we have launched recently that will have value not only to teachers but also to the Filipino STEM students. So yun po. Again, welcome to Filipino Science Hub. Marty?
All right. So again, welcome po sa Filipino Science Hub and thank you, Kuya Jeff, for that introduction of our group. We will now proceed to the talk of Dr. Dindi Voils for the introduction of organic chemistry. So kung nandito na po kayo last time, kung nandito na po kayo last time at nakasama na po namin kayo, nakapag-lecture na po si Ma'am Dindi for the introduction of analytical chemistry. So for today, she will be tackling organic chemistry and this is perfect timing kasi po yung ibang universities, lalo na po yung mga nag-shift ng calendar, kaka-start pa lang po nung SEM nila. So this will be a good leverage for the rest of the semester. So next slide please, Kuya Jeff. So mamaya po after the talk, we will be posting a Google form for registration for the web lecture giveaway. So we will be posting the Google form in the Zoom and YouTube comment section, and you will get a chance to be one of the 2 winners of an organic chemistry model kit. Next slide, please. So, ayan. Kuya Jeff?
I think we can proceed with the lecture.
Okay, sige. So, without further ado, I'll give the floor to Dr. Dindi Voils.
Thank you, Marty and Dr. Jeff. So, magandang umaga po sa ating lahat. Thank you for joining us. Just like what Marty said, it's a Sunday there. I know Sunday's special day for most of us. Salamat po for being here with us today. So, let me just share my screen real quick. and then I can proceed to the talk. Okay, so yeah, so our the web lecture today is Introduction to Organic Chemistry. So as the title implies, puro basics po tayo, no, sa organic chemistry, and parang springboard lang po ito para sa mga magte-take ng mga science courses. And if you're just interested also, this is a good starting point. So organic chemistry is a big field, no? Maraming dapat aralin dyan. But today we'll do our best to cover as much basics as possible. And like what Marty said, we're going to entertain questions at the end of the web lecture. So here's the outline of the web lecture that we will try to cover for the next 1.5 hours or so. First, I'll share some introductory remarks on organic chemistry, and then I'll be talking about characteristic features of organic compounds. And then the third part of the talk is drawing organic molecules, which is quite important in organic chemistry. And then briefly, we'll be talking about the functional groups or the families of organic compounds. And the simplest of which is the alkane. So I will also just be scratching the surface about alkanes. And then after that, we'll try to answer the question, why do alkanes make good fuels? And then the final part of the talk is isomerism in organic compounds. So introduction, let's define what organic chemistry is. Simply put, the organic chemistry is the study of the structure, properties, composition, reactions, and preparation of carbon-containing compounds. So meron tayong disclaimer, ano? Not all compounds that contain carbon are organic compounds. So here are some of examples of carbon-containing compounds that are not considered as organic compounds. So you have carbon monoxide, carbon dioxide, cyanide, thiocyanate, and carbonate. So ang original classification kasi ng organic compounds noon, they thought the organic compounds only came from living things. So, pero over the years, they were able to synthesize organic compounds using inorganic raw materials. So that definition changed right away. Pero yung distinction between organic compounds and inorganic compounds kind of stayed the same, where inorganic compounds typically come from ores and minerals. So, ang dapat nyong siguro tingnan sa structure to consider one structure as an organic compound is at least one carbon-hydrogen bond should be present. And that's how you would classify the compound as an organic compound. So let's differentiate the properties of organic compounds and inorganic compounds. For example, we have butane, no? That's the compound present in your common lighters. At room temperature, it's gas, but it's under high pressure when it gets filled up. So that's why it's in liquid form. And then we will compare that with the properties of a very popular inorganic compound, which is sodium chloride, or just your regular table salt. So organic compounds exist as discrete molecules with much weaker forces of attraction. You know? So compared to the very strong interactions of present in ionic compounds. So we can see in this table the different properties of butane and sodium chloride. So in butane, the bonding present is covalent, or the sharing of electrons, and whereas sodium chloride, it's ionic, where there is transfer of electrons. Physical state, like what I mentioned earlier, butane is gas at room temperature, whereas sodium chloride is solid at room temperature. And as you can see, boiling point and melting points are lower for butane compared to sodium chloride. And then solubility in water, organic compounds are uh, typically non-polar molecules, so they are not soluble in water, which is a polar molecule. And sodium chloride, it forms ions in water, so it easily dissolves in water, so that's why it's soluble. And solubility in organic solvents, butane is soluble, insoluble, sodium chloride is insoluble, and then finally flammability, butane is flammable and sodium chloride is non-flammable. So um, simply put, yeah, the properties between the two types of compounds are due to the differences in the intermolecular forces of attraction. All right, so before we talk about the characteristics of organic compounds, I wanted to share, I wanted to tell briefly that organic compounds are actually in our everyday lives. So this slide just shows you different products that contain organic compounds. So your clothing, soap, coffee, food, medicine, and oil and gas, all of them contain organic compounds. And even the syringe, the plastic syringe that's used in the medical field, PPEs, even ourselves, we have organic compounds. So dito po natin makikita yung importance ng organic chemistry because it affects our daily lives. So it's so important that we understand the fundamentals of organic chemistry kasi nga a lot of our products, we depend on whether it's synthetic or natural. A lot of them are affecting our daily lives. So because of this, marami actually in career opportunities ng organic chemists. And I was just telling the group earlier, I wish I was an organic chemist kasi maraming yung opportunities. So which industries hire organic chemists? So here's just a short list of industries and companies that want organic chemists in their organization. In biotechnology, you probably heard, probably Monsanto is the most popular. In the chemical industry, you have all these chemical companies, BASF, Bayer, Eastman, Dow, and so on and so forth. And of course, ang mainit ngayon yung sa pharmaceuticals, you have Pfizer, AstraZeneca, and all these pharmaceutical companies. Mainit sila ngayon kasi because of the COVID-19 vaccine. So a lot of their scientists there are organic chemists. So makikita nyo that there are different career opportunities kung ipupursue nyo yung organic chemistry. So this is just to encourage you guys na, especially for those who are taking organic classes right now, na nahihirapan, this is like the light at the end of the tunnel. So marami pong may gusto ng organic chemists. All right, so that's my introduction. Let's proceed to the characteristic features of organic compounds. So here's a periodic table just showing the main group elements. So ang emphasis ko lang dito is the carbon, nitrogen, oxygen, and fluorine, simply because these are the ones that you will see in organic compounds. But most especially carbon, ang kailangan nating i-highlight. So you will see on the periodic table that carbon is in group 4A, which means we learn in Gen Chem that it has 4 valence electrons. So carbon being a strict follower of the octet rule, gusto lagi niyan 8 valence electrons ang nakapaligid sa kanya. So in other words, it will always have 8 bonds. Not 8 bonds, 8 electrons, 4 bonds in the chemical structure. And later on, I will show you the common bonding patterns of carbon, nitrogen, oxygen, and fluorine. So lagi lang po nating tandaan, carbon will always form 4 bonds because of the octet rule. So all organic compounds contain carbon atoms and most contain hydrogen atoms. So carbon always forms 4 covalent bonds and hydrogen forms 1 covalent bond. So we learned in Lewis structures that a dash pertains to a 2 electron bond. So this is an example of carbon containing organic compound, organic compound, which is methane. But it can also form, carbon can also form single, double, and triple bonds to other carbon atoms. So for example, ethane, so it has 2 carbons in the structure, but it can also form 2 bonds. So when the carbons form 2 bonds to each other, nawawala yung isang hydrogen, because like I said, carbon is a strict follower of the octet rule. So if we still add the hydrogen there, then it will not follow the octet rule, okay? And acetylene has 3 carbon-carbon bond, 3 triple bond. So again, because of the octet rule, it only has 4 bonds around each carbon. So nawala yung dalawang hydrogen, so you only have 1 hydrogen on each carbon. So just a side note, ethylene is an important starting material in the preparation of the plastic polyethylene. So you will, if you see that symbol, PE, it means polyethylene. And this is for, it's a symbol for recycling. And then acetylene produces a very hot flame. So that's what's being used normally in welding torches. Some compounds have chains of atoms and some compounds have rings. So for example, propane, which has 3 carbons in the structure, so it's a chain of atoms. But it can also form a ring. So when it does, we now call it cyclopropane. Organic compounds may also contain elements and other than carbon and hydrogen. And any atom that is not carbon or hydrogen is called a heteroatom. So here's a table of the common heteroatoms as well as the bonding patterns of each element that is typically present in organic compounds. So as mentioned earlier, hydrogen only forms 1 bond because it can only allow 1 extra valence electron to be stable. And then we've already shown that carbon is capable of forming single, double, and triple bonds. So hindi ko pinakita itong, third bonding pattern. So carbon actually can have 2 double bonds on both sides. It still follows the octet rule. So as long as you have 4 bonds around it, that's fine. And then nitrogen, which is in group 5A group, again, it's a strict follower of the octet, but it's capable of forming single, double, and triple bonds. So again, note the number of electrons around it. So sometimes you can also form another bond, but the nitrogen gets a positive charge. So I'm just talking about the neutral state, of these atoms. Pag walang charge, ito yung common bonding patterns ng nitrogen. For oxygen naman, you only have single bond and double bonds. And sometimes you will see sulfur also in organic compounds, so it's capable of forming single bonds. And to follow the octet rule, you have 2 lone pairs. 2 pairs of lone electrons. And then finally, we have group 7A. So you have that fluorine, chlorine, bromine, and iodine. So all of them can form, or typically form a single bond in an organic compound. So ito, pabaon ko sa inyo to kasi I work in the industry, but I'm still an educator, and I've been teaching this course for the past 6 years or so. And yun, ito yung common error sa pag nagda-draw ng organic compounds is nakakalimutan yung bonding patterns. But make sure to remember that these are all strict followers of the octet rule, especially the carbon, nitrogen, oxygen, and the halogen group. All right, so the next section of my web lecture is drawing organic molecules. So, napakahalaga that we know how to draw organic molecules, because otherwise your chemical reaction will be incorrect. Okay, so there are many ways of representing the structures of organic compounds. So here's a summary. Sometimes we represent it as a molecular formula, although this one doesn't really tell us much, so because there are quite several molecules that will have this molecular formula. And that's why we have a condensed structure. You will see better the connectivity of the or the placement of the hydrogen atoms on the structure. Now, Lewis structure is what's also called an expanded structure, and you will actually see the bonds between carbons and the bonds between carbon and hydrogen. And then we also use what's called a skeletal structure. So from the name itself, you only draw the bare minimum, the skeleton of the structure. So each stopping point corresponds to a carbon atom, with the knowledge that each carbon is a strict follower of the octet rule. So kung walang nakakabit dyan, it's already automatic na hydrogen yung naka-attach sa carbon. Okay, and then of course we use the ball and stick model to show that organic structures are not flat. So they actually are three-dimensional structure. And one thing I don't have on this is the space fill model, where yun nga, para silang I'll show you later how space fill model is, but actually for me that's a more accurate 3D representation of organic compounds. Mas madali lang ma-visualize whenever we use the skeletal structure or the ball and stick model. So let me just give you a brief step-by-step process. How do we draw skeletal structures? So the first one is to determine the number of carbons from end to end. And then we draw the carbon skeleton as a zigzag line. So each stopping point corresponds to a carbon. And then whenever there's heteroatom, we draw the bond to that heteroatoms. So for example, you have butane. You see first step is to determine the number of carbons from end to end. So here you have 1, 2, 3, 4. So you have 4 carbons. And then here, this is just to show you that each stopping point corresponds to a carbon. And the last picture here is the actual skeletal structure. So bakit gumagamit ng skeletal structures ng organic chemists? Well, a lot of organic compounds are long chains, long chains of hydrocarbons. So minsan it's cumbersome to write the condensed structure or the Lewis structure. So this is just a shorthand notation of those structures, and para hindi siya cumbersome for organic chemists. So that's why we do the skeletal structures. So I have other examples. These are actually my handwriting, because I don't have a program for drawing structures. But so for example, you have 2-methyl pentane. So as you can see here, the chain on the horizontal line has 5 carbons. So that's 1, 2, 3, 4, 5. Okay, so I have 5 stopping points. And then there's a methyl group on the second carbon from the left. So I only draw one line. One stopping point means one carbon. Okay? So again, we don't include the hydrogens. Automatic na yan. So organic chemist na kapag walang nakakabit, it's a hydrogen. Okay? Hydrogens complete the complete the octet full around each carbon. So paano pag may double bond? So it's the same thing. You draw the chain as a zigzag line. So 1, 2, 3, 4. Pero yung pinakahuli, you can write just another dash. So like that. So 1, 2, 3, 4, and then this one denotes that it's a double bond around these two carbons.
Makita yung ano niya.
And then, so likewise, if you have a heteroatom, first draw the longest chain, okay? So, and then connect the substituents. So that will be your methyl group and your bromo group, okay? So here, let's see, so I have 5 stopping points. And then yung pang-anim, nakakabit na dun yung bromine, okay? So whenever you write the symbol of the halogen, automatic na, hindi na yung carbon, okay? Kasi may bromine na doon. So, and then, of course, you have to include the methyl group on the third carbon from the left. So 1, 2, 3. Again, only one stopping point kasi nga, isang carbon lang naman yung nandun. Okay, so here's the Lewis structure of 2-propanol, okay? So same drill, count the number of carbons. So that's 1, 2, 3. And then, ikabit sa pangalawa yung hydroxyl group. So the structure for that will be something like this, okay? So in the skeletal structure, you don't draw the lone pairs. You draw the lone pairs on whenever you draw the Lewis structure. So that's the general, walang lone pairs sa skeletal structure. Ayan, so kanina I said, sometimes your organic chemists deal with long chains. So instead na isulat yung buong formula na ganyan, we can write it like this. Nakikita niyo pa ba yung structure? I cannot see it from here.
Yes.
Okay, kita pa. Okay. So, ayan, no, but mag-ingat kayo kasi you make sure you count the number of your stopping points. Ayan, bilangin lang yung carbons equal to the number of stopping points on the zigzag line. And then on the end, ang nakakabit sa carbon ay hydroxyl group and double bond O. Okay? So that's how you draw simple skeletal structures for organic compounds. So let's see. So yun nga, minsan you will encounter rings, and the skeletal structures for these cycloalkanes will simply be the polygons. So cyclopropane will simply become a triangle, and then cyclobutane, since you have 4 carbons in a square, so magiging square lang yan. Cyclopentane is pentagon, and then cyclohexane will be hexagon, and so on and so forth. So the process is the same. Just make sure to count the number of your carbons on the structure. Okay, so we're very good on time. The next portion is just a brief talk. I don't think I would say brief, but I will give examples of each functional group. So I will show the structure, the name of the functional group, the structure, and then the some examples of organic compounds that contain these functional groups. But first off, what is a functional group? So a functional group is an atom or a group of atoms with characteristic chemical and physical properties. So it could contain a heteroatom, a multiple bond, or sometimes both a heteroatom and a multiple bond. So a functional group determines the molecule shape, properties, and the types of reactions it undergoes. So there are trillions of organic compounds, both naturally occurring and synthetic, and there's so much more to discover. There's so much more to make, but we can actually group them into families or functional group, which is based on the some structural characteristics, and these functional groups behave the same. So thankfully, you don't have to know all the 1 trillion organic compounds out there, but you should just be able to recognize a functional group, and you'll be able to understand the chemistry of an organic compound. So the most common functional groups can be subdivided into 3 types. So we have hydrocarbons, compounds containing a single bond to a heteroatom, and then compounds containing a C double bond O group. So let's talk about hydrocarbons. The hydrocarbon, from the name itself, it only contains carbon and hydrogen. That's why they're called hydrocarbons. So there are 4 family members. We have alkane, which I've been talking about earlier, since earlier. So actually, alkanes do not have a functional group, and it only contains the carbon and hydrogen single bonds. So if you have single bonds only, the family member is alkane. And so after that is alkene, which has a carbon-carbon double bond as the functional group. And then for carbon triple bond, carbon-carbon triple bond, you have alkyne. And then aromatic hydrocarbons will have the planar ring structure based on benzene rings. So this is the benzene ring. So it's a hexagon with alternating double bonds in the structure. Okay, so that's the hydrocarbon. Okay, so I mentioned earlier ethylene is an important precursor to the polymer polyethylene. So this is just a generic reaction. So you undergo you introduce a catalyst and let the ethylene react to form polyethylene. So just a side note, polyethylene was first introduced in the 1930s, used as insulating material for radar during World War II. So ngayon, especially here in the States, it is now a plastic in milk containers and Ziploc bags and plastic wrapping. So over 100 billion pounds of polyethylene are manufactured each year. So I know a lot of companies that make polyethylene are working hard to see, how to reuse this materials or recycle these materials to make new compounds. Because as we know, plastics don't really degrade naturally. So there are efforts to recycle these products. And kayo rin, if you're using plastics and that you can recycle, please do so. So these are single-use plastics. So hydrocarbon example in real life also include ethene. And so nakita na natin itong structure earlier. It's actually a ripening hormone in plants. Okay. And also you will see alkenes in what's called terpenes. So these are the compounds that you will see in fruits and in pine cones. So carrots have what we know they have beta carotene. So that's the structure of beta carotene, which is a pigment in carrots. So you can see it's an alternating double bonds in the structure. And then you have alpha pinene. I know sa Pilipinas wala tayo nito, but yeah, you can find it in pine trees. And then limonene in citrus fruits. So I'm giving all these examples because I want to mention, I know some of you guys are participating in Lions Den. So, these are just some ideas, because organic compounds are everywhere, and you can probably create a proposal based on isolating certain organic compounds in different materials. So this is just to give you some examples of possible investigatory projects, or for research proposals alliance then. Okay, we're still in hydrocarbons. So the poison dart frog secretes a poison that contains 2 alkyne functional groups. So you see in the structure, you have triple bonds on these structure. I don't think merong ganito sa Pilipinas. I'm not aware. And of course, we have naphthalene, which makes up the mothballs. So benzene, earlier I showed this structure to you. So this structure is also equivalent to this other structure where the double bond started on the left side of the ring. And you will also see the structure of a hexagon with a circle inside. So pare-parehas lang sila. And because in reality, electrons are not stationary. So whenever you have a double bond, you have what's called a pi electron. So sila yung gumagala sa top and bottom ng ring. So you can see here yung green shaded area here. This is where you can see the electrons hanging out. So hindi sila naka-steady lang. That's why actually this is a more realistic representation of a benzene ring. So tobacco smoke produces many polycyclic aromatic hydrocarbons. So you can see the structure. You have phenanthine and benzopyrene. So that's it for hydrocarbons. Let's move on to the next group, which is compounds containing a single bond to a heteroatom. So the first one is alcohol. And alcohol has carbon attached to a hydroxyl group, okay? So the alcohol can be primary, secondary, and tertiary. And by the way, in organic chemistry, you will always see R, the letter R, which represents the rest of the molecule. Wala pong element na letter R lang, So whenever you see that on organic chemistry structures, it just means the rest of the molecule. So primary, as you can see here, you have another carbon here connected through the rest of the molecule, and then you have 2 hydrogens. And then secondary, you only have 1 hydrogen, and then tertiary, you don't have hydrogens at all around the carbon directly attached to the hydroxyl group. So an example of an alcohol compound with the alcohol functional group is a sorbitol, which is a low-calorie sweetener. And of course, we know ethanol. It's present in our hand sanitizers and, of course, in alcoholic beverages such as wine and beer. So just a side note, for wine, ethanol is formed by fermentation of sugar, but you can also form it in the lab. So both are ethanol, whether it's produced in the lab or produced via fermentation. But of course, it's not advisable to drink ethanol that you produce in the lab. So, but they have the same structure. Okay, so the next functional group is phenol, or sometimes called aromatic alcohol. So the structure here, you have a benzene ring with a hydroxyl group. Okay, so the entire group is phenol. Pag meron siyang benzene ring na kakabit sa OH. So an example of a compound that has a phenol group is the estradiol, which is the primary female sex hormone. The next one is ether. So ether is, it has oxygen attached to two carbons, two adjacent carbons, which which contains the rest of the molecules. An example is diphenhydramine, the active ingredient in the antihistamine Benadryl. So you can see here the oxygen is attached to two carbons. Okay, walang hydrogen, but they are attached to two carbons. So another naturally occurring compound that has ether is THC, which is the primary active constituent in marijuana. So here, or it stands for tetrahydrocannabinol. So you can see here there's an oxygen on this part of the structure. You have oxygen and directly connected to carbon. And yung pinsan niya, which is cannabidiol or CBD, as you can see, wala na yung ether, no? So instead, you have hydroxyl group or a phenyl group actually here on this side, and you have an alkene on the structure. So different structures mean different properties, and that's why CBD is known to have not to have the psychoactive effect of the THC kasi nga iba yung structure niya. So the next group is the sulfur-containing functional groups. So we have thiol, sulfide, and disulfide. So thiol has a sulfur attached to hydrogen. And again, sulfur is still connected to the rest of the group through a carbon, okay? And then sulfide or thioether, which is the sulfur connected to two groups through a carbon. And then disulfide would have two sulfurs connected to each other, and then two groups of molecules attached to each through a carbon atom. So an example of a thiol group compound containing a thiol group is the amino acid cysteine. So here you can see that SH is connected to a methyl group on the amino acid. And then you also have amino acid methionine for showing a sulfide functional group. And I don't have an example of disulfide bond, but if you have a curly hair, most likely you have a lot of disulfide bonds. So when you do hair treatments, that's what is being disrupted, the disulfide bonds, because these are the ones responsible for your curly hair. So tell that to your hairstylist next time to sound smart. Please remove my disulfide bonds. Ayan. Okay, so the next group is the amines and protonated amines. So kind of like your alcohol, but instead of oxygen, you have nitrogen, okay? So we have primary, secondary, tertiary, and quaternary. So primary amine, you have two hydrogens attached to the nitrogen. And then secondary, you have one hydrogen. Tertiary, you have no hydrogen at all. Quaternary, you still don't have hydrogen, but you have a fourth group attached to nitrogen, producing a positive charge, okay? So primary amine example would be that of amphetamine, which is a stimulant. And then quaternary amine, an example is the quaternary amine in neurotransmitter acetylcholine. And of course, you have the protonated amine in amino acids, okay, which typically present in biological conditions. Okay, so that's for the second group, a functional group. I hope I haven't lost you guys yet. Feel free to wave if you're still there. All right, so the third functional group are compounds containing a C double bond O group. So you have aldehydes and ketones. So aldehyde, as you can see here, the functional group is a carbon attached to an oxygen by a double bond and hydrogen. And ketone, on the other hand, has C double bond O, but it doesn't have a hydrogen, but connected to two adjacent carbons. So an example of aldehyde would be benzaldehyde, which is can be used as an amylase flavoring. And then for ketone, an example is acetoacetic acid, byproduct of fatty acid metabolism. So ito rin yung uso ngayon, yung keto diet, which is just a low carb diet and higher fat diet. Because with that mechanism, you're actually producing, so you're using up more fats, and then the fat gets converted to fatty acid and ketones. And yung ketones, siya yung ketone bodies. So sila yung magre-replace sa glucose, which is what we need for, to function, for our brain to function. But yun yung fat ngayon for keto diet. The next group is the carboxylic acid. So the functional group has a carbon attached to a hydroxyl group and a double bond O. Okay, so an example is oleic acid, which is a monounsaturated fatty acid. I have a table of all the fatty acids, of some fatty acids. And as you can see here, it's a long chain, right? There on the end, there's a carboxylic acid. And we also have ester. So the ester is quite similar to carboxylic acid, but instead of hydrogen, the oxygen here is attached to another group, okay, bonded through a carbon atom. So an example is a triglyceride containing 3 esters. So, of course, we have this acetic acid, which is has a carboxylic group, and it is the active ingredient in vinegar. And esters, on the other hand, they are normally used for flavorings, okay, because they have characteristic smells. So I remember in college we make isoamyl acetate, which is the banana flavoring. So here in this, if you see this table, you just it's also called pentyl ethanoate. So ito yung na-achieve namin sa lab in undergrad. But esters are formed from alcohol and carboxylic acid. So if you just combine, the two, you will achieve a certain flavoring. Okay, so ethyl butanoate, it will have a pineapple flavor. So the website is there, so you can feel free to visit that website. I think it's a neat table to show, especially for those learning basic organic chemistry. So here's what I mentioned earlier. It's the table of fatty acids. But first, let me show you the saturated fatty acids. So fatty acids contain a long chain of hydrocarbons, but in the end, you can see the carboxylic acid. So an example is lauric acid, which is in coconut. And then what else is familiar here? The animal fat has stearic acid, and then canola has behenic acid, and then peanut has arachidic acid. So as you can see, it's a long chain. And again, the commonality is the presence of carboxylic acid group. Okay, so saturated means single bonds, walang multiple bonds. And then the other type of fatty acids is the unsaturated fatty acids. So like your saturated fatty acid, you have the carboxylic group, but on the structure you will see for unsaturated you have multiple bonds. So for example, palmitoleic acid, which is present in butter, okay, you will see a double bond here in the structure, and so on and so forth. The next group containing a C double bond O is what's called amide. So amide has C double bond O and also attached to a nitrogen. And this is actually the bond or the functional group that is present in proteins. So if you study biochemistry, we'll learn later on that amide bonds is present in the protein backbone, and the substituents are dangling on the protein backbone. Okay. All right. So that ends the talk about the different kinds of different groups of functional groups. So the next few slides, I'm just going to show you that different compounds can have different functional groups in their structure. So for example, amoxicillin, which is an antibiotic, and alam ko lahat tayo nakainom nito, no, pag nagkakasakit, ito talaga yung ating default. So as you can see, we have, it looks complicated, pero if you know the functional groups, you will recognize how these compounds will behave, you know, in especially in our bodies in aqueous environment. So A is a phenol group, B is an amine group, C is amide, and D is a carboxylic acid. So next slides are just to show you that different compounds have different, or pharmaceuticals are organic compounds. So ibuprofen, yan yung structure, you have an aromatic ring and then a carboxylic acid, and then epinephrine this is also an antihistamine. You have phenol group, alcohol group, and amine group. And then lidocaine, which is the local anesthetic used in dentistry and minor surgery. As you can see, you have the aromatic hydrocarbon, an amide group, and an amine group. So vitamin A, you can see on the structure, you have alkene, and you have an alcohol group. So this is just a list of food sources of vitamin A. And of course, COVID-19 vaccine contains organic compounds. It also contains salts to stabilize it, but a lot of it has, a lot of the components are organic compounds. So this is publicly available information. I just looked up for the structures of the compounds. So you have lipids in the Pfizer COVID vaccine. Ito yung lipids na pinablis na included sa vaccine nila. As you can see, it's composed of different functional groups. And of course, the main component is an mRNA. So it's a nucleoside modified mRNA. This picture is just an example of what a nucleoside is. I'm not saying this is the actual mRNA. Yeah. This is just an example of a nucleoside. So it contains a 5-membered ring sugar. We call it ribose, and then it could be a purine or a pyrimidine ring. So when they react via a condensation reaction, they connect to each other to form a glycosidic bond. So it becomes a nucleotide kung meron kang phosphate group dito sa OH dito. So like I said, this is just an example, and I just wanted again to emphasize na organic compounds are everywhere. So talagang maraming sakop, maraming opportunities for if you pursue organic chemistry.
Okay, actually that's very interesting, Professor Dindi, no? Kasi one thing that we would like for our teachers and students to realize is that the fact that organic compounds are ubiquitous. Ibig sabihin po, kahit saan kayo tumingin dyan sa paligid, makakakita kayo ng organic compounds. Even comets, meron mga organic compounds na nag-exist sa outer space. So these are some of like the basic building blocks of living and some non-living organisms as well, and non-living objects. So Yun po, that's one thing that we would like for you to appreciate na yung gaya nga po ng na-share ni Professor Dindi, marami pong iba't ibang klase ng functional groups at itong mga functional groups na to ang nagde-dictate kung paano ba sila magpa-function, ano ba yung mga ginagawa nila, ano ba yung role nila sa environment, anong role nila sa mga katawan natin, anong role nila for example dito sa COVID-19 vaccine. So baka po akala natin ano lang siya, parang liquid lang siya na itinuturok sa atin. There's a lot of components po that go into these vaccines at yung pong properties nila ay idinidikta ng iba't ibang functional groups at ng kanilang structures. And kaya po gusto namin introduce sa inyo yung organic chemistry is to raise your familiarity of the potential applications of all these compounds, and also ano ba yung mga career opportunities, ano ba yung positive impacts ng organic chemistry and organic compounds sa society. So napakarami po gaya ng sinabi ni Professor Dindi. And actually, sa-segue muna ako para makapag-break ng a few minutes ang ating speaker kasi para po makapag-rest ang kanyang boses. Let me share my screen with you because I would like to share with you some very important facts about our speaker, si Professor Dindi Yu po. So let me allow me to share my screen. Alright, so please tell me now, nakikita nyo ba, JP, Dindi?
Yes po.
Alright.
Yes.
Okay, thank you. So ang ating pong professor ngayon na naghahandog po sa inyo, nagbabahagi sa inyo ng kanyang kaalaman ay nakabase po sa Kentucky dito sa Amerika. So actually anong oras na ba diyan? It's already 9:10 in the 10:10 in the evening po. Alas 10 na ng gabi doon sa Kentucky. So maraming salamat Professor Dindi for doing this for the FilSciHub community. So just a few very important trivia po about our speaker. So ang atin pong speaker ngayon, she's from Laguna. She's from Calamba if I'm correct. Nag-aral po siya ng Bachelor of Science in Chemistry from the Institute of Chemistry in UP Los Baños. She graduated I think like back in 2004, and then after that po nagturo siya sa UP Los Baños for quite some time, for a couple of years, before po siya lumipad papuntang Amerika para mag-aral ng kanyang PhD in chemistry degree sa University of Houston. At dun po sa University of Houston, ang ginawa po niyang pag-aaral para makuha ang kanyang doctorate degree is ang pag-develop ng instruments for detecting molecules and cells labeled with magnetic particles. So at she developed I think like a benchtop atomic magnetometer. So medyo high level po ang kanyang inaral because it's physical chemistry based, which I think for most of us we consider it to be like one of the most difficult areas of chemistry. After that po, I think after graduating from her PhD, she has established a fairly well decorated career. So after po nun, she worked in a number of different areas. So in environmental industry, biotechnology, food and chemicals manufacturing. So at the moment po, ang atin pong professor ay assistant professor of chemistry sa Louisiana State University based in Alexandria. And then at the moment po, she recently started a job po with one of the world's biggest paint and coating companies po based in Kentucky. So siya po ngayon doon ay quality assurance and technical manager. So we're actually very lucky to be graced by her presence, and we're very thankful for her act of volunteerism. She's really enjoying sharing her knowledge po with all of you. So I need one very good news po that we would like to share with you is that she's committed her time to deliver lectures every couple of months. So marami po siyang i-introduce na chemistry of areas sa inyo. So mahaba-haba po ang pagsasamahan natin with Professor Dindi, and she's also the head of FilSciHub's international program. So makikita po ninyo later on, marami po kami mga scientists na hindi lang po mga Pinoy, pati po mga ibang lahi, magaling sa ibang bansa at sa iba't ibang larangan na ipapasok po natin sa ating platform para po i-introduce kayo sa iba't ibang areas ng sciences. So watch out for that po, and we do have a schedule of events, almost every week po. Meron kaming webinars and training programs. Okay, and then one very important thing po that I would also like to share with you are some of our programs sa FilSciHub and sa FilSciHub Research University that will be shared with you by JP Onya. So did my presentation switch to the right screen, JP? Can you?
Yes po.
Okay, thank you. Okay, so what I would like to share with you are the programs that we have for FilSciHub Ed. So ito po para sa lahat ng guro at sa lahat ng mga mag-aaral. What do we have with FilSciHub? Like what programs do we have under FilSciHub Ed? So FilSciHub Ed is the subdivision of FilSciHub that focuses on STEM education. So gaya po na sinabi ko kanina, we would like to empower our STEM educators and ensure that our teachers can deliver high quality STEM teaching to our students. And this particular program is led by Janice Avarilla and John Marty Mateo. So John Marty Mateo is a scientist and is a scientist based in the Institute of Plant Breeding in UP Los Baños, while Janice Avarilla is a research scientist in Kansas Medical Center here in the US. So sila po yung nagli-lead ng program na ito together with three young staff members which I will whom I will introduce later on. So ano po bang contents ang meron tayo sa FilSciHub Ed? So we started this program po by delivering teaching webinars. So essentially over the past 10 months we have been conducting teaching trainings po para matulungan po ang ating mga guro kung paano ba magturo sa bagong pamamaraan. Kasi po dahil sa pandemic with the global lockdowns and all, paano ba yung mga makabagong pamamaraan? And what we've done before was we invited seasoned professors po, seasoned Filipino professors based abroad, and we deliver teaching webinars po. So ito pong mga recorded trainings namin over the past 10 months. You can find them on our YouTube channel and also on our official website. So meron po kami talagang specific webpage dedicated to all of our recorded teaching webinars. So doon po sa mga teachers na hindi po to nakita, pwede nyo pong i-check yun kasi meron po kaming mga sample contents when it comes to assessment. Paano po ba mag-come up ng proper strategies for assessing your teachings from a distance? Yung mahalaga po yun. And then secondly, meron rin po tayong mga webinar specific kung paano po ba kayo magde-design ng approach kung paano magturo virtually, depende sa kung ano yung applicable sa inyong locality or sa inyong kung ano resources ang meron sa inyo. So lahat po ito ay nasa ating website. Okay, in addition to that po, aside from empowering our teachers, we actually wanted to help you generate teaching modules po, as well as practice problems para po magamit ng mga guro at ng mga mag-aaral. So very recently, just a month and a half ago, we launched FilSciHub's modules program. So what we did was we recruited 3 mathematics and science teaching majors from the University of the Philippines, Los Baños. So we have IMG Aguila, Ivy Retuya, and Mark Cortez. And so what they've actually been doing for the program, for FilSciHub Ed, is that they are creating and curating teaching modules in biology, chemistry, and physics. So sa ngayon po, ito muna pong 3 foundation courses ang aming ginagawa ng modules, and each teaching module is composed of a teaching guide. So kung ano po ba yung mga MELCs na pinaprescribe ng DepEd. So ginagawa po, we make sure na nakalinya po ang aming content sa kung ano po ba ang standards na ini-expect ng DepEd na i-deliver sa ating mga mag-aaral. Ang isa din po namin ginagawa sa programang ito is we actually look around kung ano ba yung mga openly accessible na teaching or class activities that our teachers can prescribe to our students. So ngayon po kasi hindi kayo makapasok sa lab, hindi kayo makapag-perform ng activities sa klase. So what we do dito po sa mga modules na ito ay sinasamahan po namin ng prescribed activities. Meron ba diyang website sa pwede kayong maggawa ng simulation? Can you simulate an experiment? Can you simulate a specific scientific phenomenon using videos or openly accessible software? So yun po yung aming inihahandog sa inyo dito sa module. But what I think sets this modules program apart is the fact that we spend time para po mag-formulate ng practice problem. So kada module po, makaka-expect kayo na meron pong 5 to 10 practice problems na pwedeng gamitin, hindi lang ng ating mga guro para sa assessment, pero kung may mga estudyante tayo na gustong mag-practice para mas ma-improve ang kanilang understanding ng subject matter, pwede po kayong pumunta doon sa aming website at you can answer our practice problems. Nandun na rin po yung solution key. So bukod sa magpa-practice kayo with the given questions, we are actually giving you a guide as to how to solve these problems. So ito yung mga programa po namin ngayon sa FilSciHub Education. So i-check out nyo lang po yung aming website, ang aming Facebook page. Almost every day po we are rolling out new modules, and starting middle of this month, medyo i-improve pa po namin to kasi ang pag-delivery namin, printed modules po, so in the form of images po. So you can actually look at those modules po as they're uploaded on our website. But starting next month, we are going to come up with video modules. So kung ano man po yung information na nandun sa aming modules, we magbo-voice over po kami. So para siyang live tutorial. So meron pong discussion na ilalapat kami dito sa mga modules sa ito para lang po mas maipaliwanag namin ng mas maayos yung content ng modules. At pagdating sa problem set, mas maihihimay-himay po namin yung step-by-step approach kung paano ba isosolve ang mga practice problems. So again, ito pong mga materials na ito na aming inihahandog sa inyo ay wala pong bayad. Ito po ay ginawa po namin talaga para po magamit ng as many teachers and as many students as possible. So yun po, we encourage you all to visit all these resources. Yun po ang aming current offering sa FilSciHub Ed, and with Janice and Marty on board, expect po ninyo over the next couple of months. Marami po kami mga exciting na programs na i-roll out, and siguro po ito is a preview lang po. Expect to hear from us. We are about to start accepting teacher members po, educators, to be part of FilSciHub Education. And kung paano po ba yung mechanismo para maging part po kayo ng ating organization, i-announce po namin yan over the next couple of weeks. So watch out for that po. Ayun, so I would like to turn it over to JP because he's going to talk about FilSciHub Research University.
Okay. Let me just share my screen. Can you guys see it now?
Yes,
Yeah.
Yes.
Okay. So I just want to make it clear na we are on a gap. Babalik pa po si Ma'am Dindi, so please don't go away. I'm just here to advertise FilSciHub Research University. So FilSciHub Research University is our online campaign that focuses on scientific research and its different aspects. So we will share here the best practices, our own research experiences, and some tips and advices when you carry out your research project. So ito po yung schedule of courses namin. Ito po yung mandatory courses. We have 8. So we have here the full range of a research endeavor, starting from a research ideation, literature review, up until poster and conference presentation. So dito po natin mako-cover po namin yung entire range of a scientific project or a research project. And here are the tentative schedules. So we're already halfway through the campaign. And the next course would be on the statistical design of experiments, which will be on April 17, so please watch out for that. And ayan, so we have devised a Google Classroom for this program, FilSciHub Research University. You can access it on Google Classroom. So meron pong you can just type in Google Classroom and it can direct you to your own Google Classroom sa mga Google accounts nyo. Let me just make it clear that you can only access this if you have a Google account. Okay? So the class code is here, 4MD3CPR, but I will also post it here on the chat box, both here on Zoom and in YouTube. So dyan nyo po makikita yung compilation of the course videos, and the stream would be for special announcement and discussions. And nandito po yung mga assignments. So why do we have the assignments? So when you take a course, we will post like a link for you to obtain your certificate of participation. And after that, as a proof for your participation, you can upload a copy of your certificate in the assignment section. Okay? So because we have 8 mandatory courses, so if you complete all the 8 mandatory courses, you can get completion certificate for FilSciHub Research University. So please check out our launch program for this campaign. And ayun po, share ko yung invitation link for Google Classroom on the chat box. So please watch out for that. So I don't want to hold you any longer. So Marty, you can probably usher back Ma'am Dindi.
All right. Thank you, Kuya Jeff and Kuya JP. So before we proceed with Ma'am Dindi's talk, let me just acknowledge all the participants. So we have around 350 participants in YouTube. And of course, our Zoom is full house, 100 participants. Magandang umaga po sa inyo and thank you for tuning in. And Ma'am Dindi, are you ready to proceed?
Yes, I am.
Okay. I'll now give the floor to Dr. Dindi. Take it away, ma'am.
Okay, thank you. So let's be back, share screen. Okay. All right, so our the next section of the lecture is about alkanes. So it's the simplest hydrocarbon. In fact, the simplest organic compound, because it only has single bonds of carbon, and you have the carbon and hydrogen bonds. Okay. So like I said, if you just tune in right now, this is it's like a crash course, so to speak. Very basic po yung ating approach. So just use this web lecture as a springboard. If you want to dig deeper, feel free to do so. There's plenty of resources. Meron pong free ebooks na available for organic chemistry. So yeah, marami po tayong resources for this online. So okay, without further ado, let me start the talk about alkanes, the simplest organic compounds. So alkanes, like what I mentioned, are hydrocarbons having only carbon-carbon and carbon-hydrogen single bonds. So we have what's called acyclic alkanes, and these are the alkanes that only have chains of carbon atoms, so you don't have rings. Here's the general formula for acyclic alkanes. So CN H2N plus 2, where N is the number of carbons it contains. So just use that formula to verify if a molecular formula, if it's an alkane or not. And sometimes they're called saturated hydrocarbons. And I think I've already mentioned this earlier. If you don't have double bonds or multiple bonds, they are called saturated. So another type of alkane would be cycloalkanes. So from the name itself, and I think I've already mentioned this earlier, instead of chain, meron kang one or more rings. And the general formula is CnH2n, where N is the number of carbons it contains. So here are some naturally occurring alkanes. You have alkanes in shark liver oil and cockroach pheromones, so pristane and andecane. And in addition to esters, mangoes actually have alkanes in them. So here's some of them, and there's actually a paper showing their measurement of these alkanes. These are actually Indian mangoes. All right, let's talk about the simple alkanes, which would be methane, ethane, propane, and butane. So methane only has one carbon, and I've shown this during my early slides. And you can see here it has 4 hydrogen to complete the octet role. So minsan you will see this representation. You have a dash and a broken line. So what it means is your molecule is not flat. Okay, so the bold line, the dashed line, means to say that this bond, the carbon-hydrogen bond, is actually pointing perpendicular out of the plane. So hindi siya lang hindi ito two-dimensional, it's a three-dimensional structure. Whereas yung broken line, it's also out of perpendicular, pero sa likod siya, it's the back of the screen. So makikita nyo dito sa 3D dimensional na the black ball is the carbon, and then usually the white balls are the hydrogen. So you can see here you have three-dimensional shape. And this is what we call a tetrahedral shape, okay? If we remember our Lewis structures and geometry. So this is the common shape of hydrocarbons around each carbon. And this is what I was mentioning earlier, the space field model. So in reality, you will not see these lines, this bonds right here. This is just to aid us to visualize the bonds. Pero in reality, hindi talaga natin makikita yung mga lines na yan. It's the electrons are we can only imagine electrons as probably present there. So ito yung probability na yung electrons mo ay andyan sa structure mo. So the next simple alkane is ethane. So likewise, the shape of the ethane is not flat. And again, each carbon would assume a tetrahedral shape. Okay? And then propane has 3 carbons. So makikita natin yung structure, again, not flat. And I remember in undergrad, dito ako nahirapan na mag-visualize. If I only look at the dash and the broken line. So maganda talaga yung my model para mas ma-visualize mo yung structure ng organic compound.
Professor Dindi, actually, very good point yun na, di ba, sabi mo, medyo mahirap siyang i-visualize, no? Gusto ko lang i-point out sa mga teachers po at natin, i-try nyo pong ituruan ng abstract thinking or abstract thinking ang ating mga estudyante, yung kaya po nila mag-imagine ng structure sa utak lang nila. Pero kung hindi po talaga makakaya, pwede po kayong gumamit ng models kaparehas po nitong pinapakita ni Professor Dindi. Pero typical indication po ng mga estudyante, typical talent po ng mga estudyante na madaling ma-pick up your organic chemistry are those who can imagine the structure in their head. Yung kahit paikot-ikutin nila dun sa utak nila yung structure, alam po nila kung paano nila siya titingnan, kung how it behaves structurally. So, and ideally po, dapat yung ganun yung level ng competency yung maabot natin. Pero para po hindi ma-discourage yung mga hindi kaya mag-imagine, di gumamit po tayo ng tools. Kasi pag meron naman kayong tools, masasabayan nyo rin yung mga magagaling sa abstract thinking. Yun lang po yung parang tip na pwede naming mabigay sa inyo. And actually, meron pong mga props si Professor Dindi later on. So what I would suggest is, Professor Dindi, pag share mo na yung mga props mo, stop natin yung sharing para makakulit ka. Para kitang-kita yung structures.
Oo, kasi maliit yung video.
Yeah.
Okay, sige.
This is exciting po. At kaya po nagsabi na isip namin, this is quite fitting kasi introduction to organic chemistry, mag-share ng structure, ng tips kung paano magsulat ng structure si Professor Dindi. Ang giveaway namin ay organic model kit. So yun po. For those of you po na medyo kailangan mag-brush up sa Lewis structure, kung paano ba yung mga techniques, we have a web lecture po on Lewis structure. So organic and inorganic compounds, lahat ng mga types ng actually karamihan ng types ng structures na i-discuss ni Professor Dindi dito when it comes to alkanes. Nandun po sa web lecture namin na yan. I think it was sometime in July or August of last year. So look for that kasi from Lewis symbols, from the octet rule hanggang yung mga techniques po kung paano pagsulat ng Lewis structures, meron po kami noon comprehensive at Tagalog-English po siya para mas maiintindihan ng mas marami nating mga kababayan. So medyo patalastas lang po pero pay close attention to this. Everything that Professor Dindi is discussing is very important. Lalo po sa start ng organic chemistry nyo, because if you have a good appreciation of structures, madali na lang po yung masasabayan yung mas complex organic concepts.
Correct.
Kuya Jeff, let me just add, no, yung registration po for the raffle ng organic chemistry model kits will be sent to the Zoom chat box and YouTube chat box after po ng talk ni Ma'am Dindi. Tapos while we're doing Q&A, we will be entertaining the registrations, and then after the Q&A, tsaka po tayo magra-raffle. Ayun
Okay.
po. Thank you po.
Ayun. And by the way po, ako po ay organometallic chemist. So ako po ay pinagsasama ko ang organic at ang inorganic chemistry. So kalahati po ng aking mga ginagawa sa buhay ay nag-involve po ng organic compounds rin. So medyo pinahirap lang natin kasi yung inorganic, pinapagsama natin siya into one molecule. So yun po, that's how we build up complexity. But then magagawa niyo po ito mga mas komplikadong mga science topics or research kapag po solid ang inyong foundation sa organic chemistry. And actually, UPLB has one of the strongest organic chemistry teaching or quality of instruction sa buong bansa po. Kasi karamihan po sa amin, pag nagpupunta kami sa abroad para magpakadalubhasa, ang dami din po talagang nag-take up ng organic chemistry as part of our major. So yun po, those are things that we would like to share with you po. So may career kapag magaling kayo sa organic chemistry.
Ayun.
Thanks,
Dr. Jeff. So, yun nga, at first, organic chemistry can be intimidating kasi it's really not being taught in high school. Siguro mga science high schools lang talaga yung nagtuturo nito. No? So, ang goal po talaga ng web lecture na to is mag-provide po kami ng foundation po para pagdating po ng mga estudyante sa college, meron na silang idea kung anong kakaharap nila. Hindi sila ma-intimidate, of course. So,
totoo po yan. Kasi nag-uusap-usap kami ni Professor Dindi. Lahat kami, pagpasok namin ng UP Los Baños, wala po talaga kaming halo sa organic chemistry. And so this is one very important thing that Dindi also pointed out, that if the intimidation po, kung yung takot sa organic chemistry sa high school ay mawawala sa pamamagitan po ng pagbibigay ng overview lecture na ginagawa po niya ngayon. Marami pong estudyante ang hindi po mahihirapan siguro sa pagsisimula sa organic chemistry kasi may familiarity na po Kumpara dun sa pagdating mo ng college, diretso ka na agad sa hardcore organic chemistry courses. Well, in fact, dapat yung foundation knowledge na nakuha mo sa high school ay hindi na ibigay sa'yo. Ang dami po talagang nahihirapan. At if you are choosing chemistry as a major, ang una nyo pong sabak sa organic chemistry ay advanced agad. So doon na po talaga yung maraming bumabagsak sa organic chemistry if you're a chemistry major. But if you're prepared for it, kapag yung foundation knowledge, gaya po na i-share na Professor Dindi ngayon at sa mga susunod na lectures natin, kapag yun po ay inyong nakuha, ay handang-handa po kayo pagpasok ninyo ng kolehiyo. Ayan po. So, thank you so much. Maraming salamat talaga po sa paggawa ng lecture na ito, Professor Dindi, because napakaganda ng content kasi bukod po dun sa basics, binibigyan niya kayo ng example para may imagine niyo po ano bang silbi nito mga sulat sa libro. Kasi yun din po yung ayaw naming ibigay sa inyo na tuturuan lang namin kayo pero hindi niyo na-imagine saan ba yung application nito. Ito po talaga yung sinasabi namin kanina na culture. It's the culture of science that we're trying to deliver. So bukod po dun sa concepts, bibigyan namin kayo ng example. Yung real life example na nai-experience niyo sa pang-araw-araw. Okay, back to you, Professor.
Yeah. So one last thing, ito actually yung salaan sa mga chem majors. Kung malagpasan mo to, then you can proceed to your degree. Kasi parang ito talaga yung filter sa mga chemistry majors and even engineering majors. So, okay, so back to the ball game. So we're on butane, So butane has 4 carbons. And again, I wanted to emphasize it's not doesn't have a flat structure. So, if you have a good imagination, visualize na carbons have, tetrahedral shape. Pero again, you don't need to try super hard, because we have models available to visualize the structures of organic compounds. And malay nyo po, kayo po yung manalo sa paraffol namin at the end of the of the talk. So you will have the model to use for your teaching tools. So methane and ethane make up a tiny proportion of Jupiter's atmosphere. Okay, and natural gas actually contains primarily methane and ethane, but it has some propane and butane. So makikita po natin sa table na to that the first 4 alkanes have the special names, ano? So methane have 1 carbon, ethane has 2, propane has 3, butane has 4, and the succeeding organic compounds will start with Greek prefixes. So starting with say pentane, so you have 5 carbons, and the Greek prefix for that is penta, so that's why it's called pentane. And then hexane if you have 6, heptane if you have 7, and so on and so forth. So makikita po natin dito na the more carbons, of course, the longer the chain. So yun, ito rin yung importance ng skeletal structure is mas simplify yung organic structures, especially if you are learning about chemical reactions. Okay, so I will just give an overview of nomenclature of simple alkanes. So nomenclature means naming system. We'll talk about naming branched alkanes, haloalkanes, and cycloalkanes. So nomenclature of organic compounds is established by a group called International Union of Pure and Applied Chemistry. So it's IUPAC. Okay, so they ensure that each organic compound, whether it's natural or synthetic, there is a system that will create a unique name for those compounds, and they ensure that all the naming system is systematic. Okay, so here's the 3 basic parts of a name of organic compounds. So you have the substituent, which is an attachment, parent name, which is based on the number of carbons in the longest continuous chain, and then suffix is the family name. So since we are talking about alkanes, makikita po natin that suffix will all, for this particular compound or functional group, would end in A and E for alkanes. Okay? All right, so paano po ba natin name ang branched alkanes? So first step, you have to find the longest chain, okay, of carbon atoms. That will be your parent chain. So pangangalanan niyo po yung parent chain. And then we have to identify the attachments to that main chain. And then we have to assign a number to the number to each carbon of the parent chain. And we need to start at the end near to a substituent so that we can achieve the lowest number possible. And I have an example for this. And then lastly, we have to assign a number to each substituent based on location. And then we list the substituents in alphabetical order at the beginning of the name. So yung alkanes po, they can also be an attachment to a parent alkane chain. No? So they are called alkyl substituents. So for example, methane, if it's a substituent, nag-iiba yung pangalan, nagiging methyl. So we just change the suffix from A and E to YL. So likewise, ethane, if it becomes a substituent, it becomes ethyl, and so on and so forth. Okay? So for example, we have this skeletal structure. Okay? It's tempting to count from left to right. Kasi yan yung, yan yung nakasanayan natin. 1, 2, 3, 4. Pero if you notice there's a carbon here, you can actually start counting from the top. Okay, so I can actually count 1, 2, 3, 4, 5. So actually the longest chain in the structure has 5 carbons. carbons. Okay? Hindi po yung apat. So, this means that my parent chain is a pentane. Okay? So, the next step is to name or determine the attachment or the substituents to my parent chain. In this case, I only have what? 2 attachments, right? Dito sa carbon na to, and here the carbon somewhere in the middle. So 1 stopping point means it has 1 carbon. So 1 carbon means the name for both substituent is methyl, di ba? So ayan, na-recognize natin the 2 attachments are methyl groups. So ang next step naman dyan is to assign numbers on the parent chain. So remember, this is our long chain, and you want the lowest number possible. So you assign the one where to the nearest substituent. So here in this case, we can start from here kasi ito yung may pinaka-malapit na substituent sa dulo. So that's going to be 1, 2, 3, 4, 5. So this means that the methyl groups here are actually on carbon 2 and 3 on the parent chain. Okay, so the system is, if you have 2 similar attachments, you actually use the prefixes like mono, di, tri, tetra, pentyne, so on and so forth. So since you have 2, we use the prefix di before methyl. So 2,3-dimethyl. And then ang kasunod na lang dyan would be the parent chain. So the actual name for this compound is 2,3-dimethyl pentane. Okay? So due to time, I only really have one example for each type of alkane. Pero sabi ko nga, we have many resources online for you to practice. Okay? So ito actually, I think, yung pinakamadali sa organic chemistry ang pag-name, pero it still requires practice. And the next type of alkane is a haloalkane. So from the name itself, meron tayong halogen as the substituent, and sometimes they are called alkyl halides. Okay, so the naming system is similar to your simple branched alkanes, except yung substituent names ay names ng halogen. So for example, fluorine becomes fluoro, chlorine becomes chloro, bromo and iodo for bromine and iodine respectively. Okay, so same system, same naming system. So I have this example right here, nagkataon na pentane again, because I have my longest chain is across the horizontal chain. So that's 1, 2, 3, 4, 5. And napakita ko na siya. So again, similarly, we have to identify the attachments to the parent chain. So that's we have chlorine and we have a methyl group. Okay. So ayan, you have chloro and methyl. And again, you have to assign the number based on the number 1 based on the substituent nearest to the end of the chain. So here, pinakamalapit yung chlorine dito. So we start numbering it as 1, 2, 3, 4, 5. Okay, so that means the name will have 2-chloro, 3-methyl. Okay, so ito yung pinaka-final na name niya, 2-chloro, 3- and then methyl pentane. Okay, so the 2-chloro, 3-methyl denote the attachment to the parent chain, which is the pentane. So the last nomenclature system is for the cycloalkanes. So madali lang din siya. Yung name niya would be similar to the name of the alkanes based on the number of carbons in the ring. And you add the prefix cyclo to denote that it's a ring, okay? The simplest cycloalkane is cyclopropane, which has 3 carbons. And the rings of 5 and 6 carbon atoms are the most common in nature. So here's the structure of cyclopropane. As you can see, it's the skeletal structure is just a triangle. Okay. So here are the and I think I've already shown this to you guys, but it's a skeletal structure. We drop the hydrogens and then draw the cycloalkanes as polygons. Okay. So the rules for the IUPAC names determination for cycloalkanes are the same as those for branch chain alkanes with a few modifications. So syempre, because it's a ring and medyo may modification yung rules. So the first step, the ring serves as the parent name as long as it has more carbons than any substituent. So in other words, you still have to find the longest chain. Kung di ka makakagda ng longest chain and the ring is there, then that is your parent name. And then likewise, you have to identify the substituents and then number the carbons in your ring. So carbon 1 will always have a substituent. And then assign numbers to the substituents. So if you only have one substituent, you don't assign it as 1 on the name. 1 is already implied and it shouldn't be included. And again, you want the lowest number possible. So for example, here, the obvious parent here is the cycloalkane because I have 6 carbons, right? In the ring, and here we do have carbons, but they are not longer. They don't have more carbons than the cyclohexane. Okay, so the name is cyclohexane because hexa means 6 carbons, and then again you determine the attachments. So you have methyl and then propyl. So that's 1, 2, 3 carbons, and then methyl for 1 carbon. And then you assign 1 for methyl kasi nauna siya alphabetically, you know? So 1 methyl and then 3 propyl. And then the parent name would be cyclohexane. So 1 methyl, 3 propyl cyclohexane. And again, for practice, hanap lang po tayo ng mga resources online. Marami pong mga worksheets na merong actually answer keys to practice for this one. But it's very important to learn these para for actually future lessons po, no? More advanced lessons sa organic chemistry. Okay, so the next topic is about alkanes, making good fuels. So why do alkanes make good fuels? And the simple answer to that is because alkanes readily undergo combustion. So they react with oxygen called combustion. And I will show you the reaction, the equation for the combustion reaction. So the completely combustible hydrocarbons, they burn cleanly, and the products are carbon dioxide and water. And scientists search for cleaner, cheaper hydrocarbon fuels to replace fossil fuels. So here are some alkane fuel sources. So you have methane for natural gas, propane for propane gas, isooctane in gasoline, hexadecane in diesel fuel, and trioctane for candle wax. Okay, so here's a generic equation for the combustion of alkanes. So complete and incomplete combustion. So both of them generate energy, and also for complete combustion, maximum yung energy na nag-give off ng reaction. And you produce only carbon dioxide and water. However, for incomplete combustion, you have carbon monoxide, carbon dioxide, water, and the energy. There should still be energy here, but it's less than that of incomplete combustion. Kasi nga incomplete, so hindi lahat nag-react, no? Hindi lahat nag-proceed sa combustion, and you don't want to produce carbon monoxide, diba? So most of our hydrocarbons being used as a fuel, well, some of them do undergo incomplete combustion. So merong mga efforts, no, for biodiesel, and here biodiesel here's an example of methyl stearate, which is found in biodiesel. As you can see, the structure is similar to hexadecane, which is found in diesel, but here you have carboxylic acid. No, sorry, an ester group on the end. So there has been several researches about this, and meron na ngang gumagamit ito. So the combustion is cleaner, so to speak, for biodiesel. And pero may mga trade-offs dyan, ano? So you have to use more biodiesel for a complete combustion. And pero yung na-generate na carbon dioxide is less than that of combustion or incomplete combustion of regular fuel sources. So marami pa ring studies about this. So hopefully, if kayo gusto niyo maging organic chemist, maybe you will, if you want to study on biodiesel, that will be really helpful in the society. But of course, marami nang gustong mag-switch sa electric cars. So it's a different set of problems na pwedeng ma-encounter ng society. Although we will eliminate the use of alkanes. Okay, so that's it for alkanes. So now we will proceed to isomerism in organic compounds. Okay, so organic compounds with the same number of carbon atoms can have the carbons connected in many different ways. So if you have the same molecular formula but different connectivity or arrangements, the molecules are called isomers. So iso in Greek means the same, and then meros meaning part. So in this lecture, I will only be talking about 3 types of isomers: structural isomers, conformational isomers, and stereoisomers, which include cis-trans, stereoisomers, and enantiomers. So for structural isomers, when two molecules have the same molecular formula but a different connectivity, they are called structural isomers. So for example, butane and isobutane. You can see that the molecular formula are both C4H10 for both butanes. Pero makikita natin na you see here the parent chain is butane is just a straight chain, whereas isobutane actually is the branching, on carbon number 2. And here's the ballistic model for each isomer. So this means that since they have different structures, it means that they have different properties. Ganun naman sa chemistry, di ba? If you have different structures, iba yung exhibit nila na property. Okay, let's see. Okay, so how about this one? Is this a structural isomer or a different type of isomer? So as you can see here, so we still have butane, and both have 4 carbons, okay? Pero makikita po natin that carbon number 3 here is connected to carbon number 4 the same way as this for this molecule. Yung carbon dito, but nakakonect pa rin siya sa carbon. And this is the time when I will show the model, ano? So let me stop sharing. Yeah, nakikita nyo ba yung model, molecular model? So the first molecule, ganito yung itsura niya, no? So because of the single bond, actually, itong model, you will see that this bonds can actually rotate. Okay, hindi sila steady. So yung unang molecule ganyan siya, okay? Yung pangalawa actually is just the rotated version. And in other words, ayan, ganyan siya, no? So, but it's the same molecule. So in other words, those molecules that I presented to you are actually the same. And they are called conformational isomers or conformers, okay? So, let me go back to my screen. So again, single bonds can rotate freely around the around carbon-carbon bonds. So ang technique dyan, para malaman kung structural ba or conformational, is pangalanan nyo yung compound niyo. So if you following the IUPAC rules, right? Both of them are just butane basically. So because they have the same connectivity, technically, they are the same molecule, and they have a similar property. So this is just a little chart or a little flow diagram, a yes/no diagram, a deciding chart to determine whether the structures are conformational or structural. So do your molecules have the same molecular formula? If no, then hindi na kagad isomers yan. But if yes, then ask yourself, do the molecules have the same name? If they have the same name, they are conformational isomers. Otherwise, they are structural isomers. So dito rin natin makikita yung importance ng knowing how to name organic molecules properly. Okay, so let's move on to the cis and trans isomers, which are stereoisomers. So, makikita po natin dito is a cyclopentane, 2 cyclopentanes. So here, you will see that one methyl group, remember a dashed line means it's in front, and then one methyl group is behind, okay? Whereas the other molecule, both methyl groups are behind. And if you see the models, so makikita po natin dito, itong methyl group na to is nandito siya sa taas, and then yung methyl group ay nasa baba, and then on the other hand, this molecule both have the methyl groups on the same side. So unlike conformers, unlike straight chain alkanes na pwedeng mag-rotate around the bond, yung rotation po sa ring is very constrained. It's restricted. You cannot rotate this. So if you cannot rotate the bond, pwede pong mag-mute tayo, no? Nag-feedback ng konti dito. So naka-on po yung ating audio. So thank you po. Ayan. Narinig ko yung sarili ko. Ayan.
Yeah, I think that's good now. Yeah.
Okay, thank you.
Yeah, actually, Professor, ay, meron pa rin. May feedback.
Okay na? Dr. Jeff?
Yeah, na-mute din ako.
Malapit na tayong matapos. Konti na lang po.
But then, actually, yung very important point na sinasabi ni Professor Dindi, kapag po linear ang inyong molecule at lahat ay single bond ang nasa inyong carbon chain, yun pong inyong bonds, pwede pong mag-rotate ng 360 degrees. Lahat ng groups medyo active ang... Okay na. May narinig ko, parang sinagot ko rin yung seconds ago. So actually, very important point na sinasabi ni Professor.
Is there a way to mute everyone?
Yeah, I think if we mute,
Okay.
I just don't know why other people's
Sige.
mics are getting activated again.
Okay.
but then yeah, ito po yung mahalaga. Kapag linear po yung inyong chain, sabi po ni Professor, hindi pwede pang mag-rotate ng 360 degrees yung inyong yung inyong constituents. So kaya po meron po kayong conformational isomer. So pero pag po na siya sa ring, hindi mo nyo po pwedeng i-rotate ng 180 degrees kasi po ano po, hindi po siya pwede. Ano po, masyado, hindi po siya, energetically, hindi po siya pwede. I don't know what's going on. But then yeah, yun po yung difference na linear from cyclic structures. Okay, back to you, Professor Dindi.
Okay. Teka lang, i-mute all ko muna, no? Ayan.
Okay, yeah.
Ayan, hello po. Can you hear me now? Can you hear me?
Yeah.
Okay. So I muted everyone. Konti na lang po. Konti na lang po.
You muted everybody, including yourself.
Yes. I was going to unmute myself. Okay, so back to cyclic structures, ano? So like what Dr. Jeff mentioned earlier, yun nga sa cyclic structures, rotation is restricted. Hindi ka pwedeng mag-rotate. And for you to say that these compounds are the same, kailangan mong i-break yung bond somewhere, you know, somewhere in here. But because you can't do that, because of that constraint, we can say that these two molecules are actually different. They are isomers, okay? I mean, they have the same molecular formula, but different arrangement, okay? Different arrangement in space. So, wag po nating piliteng mag-rotate ang cyclic structure. Ayan. So, yeah, so like I said, if the molecules shown were conformers, we could change one into the other without breaking any bonds, but we couldn't do that, you know? So the ring of carbons make it impossible for one of the molecules to rotate and produce the other. So this just means that these two compounds are different, but they are isomers. And if you have a different you have the same attachments to the carbon skeleton, but different spatial arrangement, they are called stereoisomers. So in this case, it's a cis-trans stereoisomer. So cis means same and trans means anti or different. So here, this is a representation of cyclopentane with two methyl groups. So here, yung una pong picture is the methyl groups are on opposite sides, so or opposite faces. So it's a trans isomers, whereas here the two methyl groups are on the same face, so that will be the cis stereoisomer. Yeah, and of course it also exists in alkenes, where you also have restriction of rotation around the double bond. So again, these two are cis-trans isomers because the double bonds, you cannot rotate the double bonds. So I actually have a model for that as well. So let me just stop sharing my screen. And as you can see here, you know, this is the model of my example. So ito yung double bond, ano? So yung model, kahit anong pilit ko, hindi ko yan ma-rotate. Okay? So it simply means the molecules I presented are actually isomers. They are not the same molecule. So again, kung yung substituents ay nasa parehas sa side, it's called a cis isomer, and then different sides means it's a trans isomer. Okay, moving on. So the next type of stereoisomer that we will be talking about is the enantiomers. So these are compounds that are non-superimposable mirror images of each other. A very common example is the limonene from oranges and the limonene from turpentine. So ibig sabihin po, so these two are mirror images of each other. Pero pag pinagpatong niyo po yung dalawang yan, they are not, hindi sila parehas, you know, they are not superimposable. So when that's the case, these molecules are considered enantiomers. And enantiomers are, most enantiomers contain what's called a chiral center. So you know, a practical example of non-superimposable mirror images is a pair of shoes or even your hand, you know, hindi sila superimposable. pag pinagpatong nyo sila. So, objects such as these are termed chiral, which from the Greek chir mean hand. Okay, so here you can see na these two are enantiomers. They are mirror images of each other. Pero again, if you they are not superimposable. So magkaiba sila. In other words, they are enantiomers. Okay, so a very common exercise in organic chemistry is determining chiral centers. And how do we do that? Well, chiral center or chiral carbons will have 4 atoms or different groups of atoms bonded to them. So first step is to locate that carbon, tetrahedral carbon. So take note, it should have 4 bonds, okay? And then you inspect the tetrahedral carbons and the groups that are attached to it, and then assign the chiral center. So, for example, here you have 2-methyl-3-bromo pentane. So, ang first step po dyan is i-highlight po natin yung mga potential chiral centers. So, you have 1, 2, 3, 4, 5, 6. Okay, so 6 potential chiral centers. Pero nga, by definition po, chiral carbons should have 4 different atoms or group of atoms attached to it. So, hindi na po pasado itong mga carbons that have hydrogens, at least 2 hydrogens on there that are attached to them. Because, like I said, there should be 4 different attachments. So ngayon, dalawa na lang yung posibleng chiral centers, right? Pero if you look closely, this carbon also is not chiral center kasi it's connected to a hydrogen, and it's also connected to 2 methyl groups and then this entire group. Okay, so this leaves us this carbon in the center. So for this structure, ang chiral center lang ay yung carbon sa gitna kasi you see it's connected to bromine, hydrogen, and then these 2 different alkyl groups. Okay? So, ito na po yung last portion ng talk. What are the consequences of chirality? So, yung mga receptors po natin, very specific yan to accommodate molecules. So, marami pong drugs, marami pong pharmaceutical products will only have a single enantiomer that has biological activity. So, minsan po, one enantiomer can be beneficial and the other can be harmful. So, that was the case for a drug called thalidomide. So, it's supposed to alleviate symptoms of morning sickness, pero yung enantiomer niya could actually cause birth defects. And ban na po itong gamot na ito. No? So this is the structure. As you can see, they are mirror images of each other, but they are not superimposable. So they are enantiomers. And these enantiomer was able, ang target po niya is yung symptoms ng morning sickness. But apparently this caused birth defects. Ano po? So yun din po yung responsibility rin ng mga ng organic chemists is to make sure that your products, dapat alam niyo yung kung may side effects yung drugs, okay, or bad side effects and things of that nature. So again, because magkaiba sila, different, they have the same chemical formula but different structural characteristics, magkaiba yung behavior nila in our bodies, okay? So iba yung properties nila. So dapat careful whenever we make products. Okay, so wrap up na po tayo now. To summarize, organic chemistry is dedicated to the study of the structure, properties, and reactivity of carbon-containing compounds. So nakita natin that there are several industries need qualified organic chemists for research and product development. So in demand po ang organic chemists. And we learned that Organic molecules can be very large, so if you just use Lewis structures, they can be cumbersome. So there's a more there's a systematic way of drawing organic molecules to simplify that you could do a condensed form or skeletal structures. Organic compounds are grouped into distinct families called functional groups. So they are based on the molecular structure and composition, and members of the family behave similarly in chemical reactions. So we learned that alkanes contain only single bonded carbon and hydrogen, and thus are considered the simplest organic compounds. So they are good sources of fuel because they readily undergo a reaction with oxygen called combustion. IUPAC developed a naming system so that each organic compound has its unique name. And finally, isomerism exists in various organic compounds. So isomers of the same molecule have the potential to have different physical or chemical properties. And these differences can have some important implications. Okay, so thank you everyone. And we can now proceed to our question and answer portion.
All
right. So,
Marty, bago
Yeah.
tayo mag-proceed sa Q&A, mag-promote muna tayo ng mga upcoming events natin. Is that okay?
sure po.
Alright, so let me share my screen. Alright, so again, bago po tayo makipagbaliktaktakan kay Professor Dindi to ask your questions, we would just like to share with you yung upcoming events po natin sa FilSciHub Ed over the next couple of months. So marami po kami mga mahahalagang events na i-offer sa inyo, and we're hoping that our students and teachers can all participate in these events. So after po nung session natin ngayon, a week from now, Saturday at 11 in the morning in the Philippines po, we have this online tanghalian with Pinay Scientist, Dr. Crisita Carmen at the end. So this is a career guidance talk featuring I think one of the most successful young scientists from the Philippines right now. So I will explain to you what to expect from this event. But that's on March 13 po. And then a week after that, March 20th, Marty Mateo, JP Onya, and myself included, we will be conducting a workshop po to help teachers and students conceptualize ano ba yung mga experiments or projects, research projects that you guys can pursue at home or within your locality. Kasi ngayon wala kayong access sa lab, hindi kayo makalabas masyado. Ano ba yung mga research projects na pwede nyo simulan sa bahay or pwede nyo gawin sa bahay? So ito po yung mga topics na ibibigay namin sa inyo. And then as an added bonus to that, ako po tuturuan ko kayo paano ba yung mag-facilitate ng brainstorming process. So if you're working with a team, paano ba kayo mag-gather ng ideas? And if in case you have more than one idea to pick from, paano ba ninyo ipa-prioritize and what is the best idea? How do you pick or how do you screen your ideas? How do you rank them? How do you pick like that one best idea that your group will be working on? So yun po, that's on March 20th. That's a Saturday at 10 in the morning. And then after that po, we have a series of special topics for FilSciHub Research University. So on March 27th at 10 in the morning, we will have Dr. Tony Cañete Gipa. So she's a world-class Filipina scientist working in the areas of mycology and taxonomy. So currently she works on fungi discovery for clinical application. So ipapakita niya sa inyo ano ba yung mga career opportunities sa area of mycology and taxonomy. And she will also be sharing with you kung ano ba yung mga families and species of fungi that she has discovered herself. As of meron po tayong mga ganyan mga scientists na nakaka-discover ng mga organismo. So this is something that you should watch out for. On April 3rd naman po, we will have a seminar workshop on data science. So ito po, napaka-applicable ito sa high school at sa college level. Students and teachers are encouraged to participate kasi dito po, we will introduce the area of the field of data science. And we invited Professor Kevin Season from St. Luke's Medical Center because he's one of the Philippines up-and-coming data science expert. So ituturo po niya sa inyo kung ano ba yung data science and magbibigay siya ng example. So dyan po sa workshop na yan, when you participate, we also encourage for you, if you have a laptop, bring it with you kasi may mga examples po para ma-practice nyo rin yung mga data science activities. So this is actually a very good seminar workshop that you should participate in. On April 10th, we have a chemometrics webinar featuring Professor Gerard Dumangcas from Louisiana State University rin po. So he's a trained chemist from the Philippines and now is a professor of chemistry here in the US. And then lastly, on April 24th po, we do have we will be featuring an American scientist. So we have Professor Chad Creighton. He will talk about cancer genome analysis. So yung mga medyo may interest po dyan sa molecular biology and biochemistry. If you're quite intrigued kung paano ba yung research sa area na yan, ano yung career, what the career is like when it comes to molecular biology and biophysics, for example, because that's his specialization, that is a webinar that you should watch out for. So ito po mga to, these are combination, yung special topics are combinations of parang career talk kasi they will talk about what they do, but then they will also share with you the things that they are actually studying in their respective fields. And then, okay, ito po specifically, next week, wag niyo yung mga estudyante at saka yung mga teachers po who are quite interested, paano ba mag-establish ng careers, ng international career sa chemistry in particular. So we will be featuring Dr. Crisita Carmen Atienza. So ito po, kung kami po, if you guys are if you guys have seen yung pong mga bodies of work namin over the years kasi pinapakita namin sa inyo ano ba yung set of credentials namin. Crisita Carmen Atienza is an idol of the entire FilSciHub team po because she graduated the very first summa cum laude of chemistry from the University of the Philippines, Los Baños. Obviously, one of the board top-notchers during her time, but then she actually went to 2 Ivy League schools. So she did her master's in Cornell University and her PhD in Princeton University. And at the moment, she is working for one of the world's biggest petrochemical companies. Yun po. So she has 5 years worth of experience in industrial R&D and she transitioned into a business role. So ang ibibigay po niya sa inyo ay she will share with you her journey as a scientist, starting at the high school level, what was her preparation like? Paano ba siya naghanda at the high school level? Ano ba yung experiences niya doon? Pagpunta niya ng college, what were the challenges? How did she become a summa cum laude? How did she top the chemistry board exam? How did she get accepted to Ivy League schools in the US? So yung Ivy League schools po, ito kasama yan lagi sa mga top 10 or 20 schools sa buong mundo. Meron po tayo mga Pilipinong nakakapasok dyan. So kung yung mga estudyante po na nanonood sa atin, if you're quite interested, if you would like to get tips kung paano ba nagagawa ng mga kaparehas po namin na makapasok sa makukuha ng mga ganitong oportunidad, this is a chance for you to hear her story firsthand. And then what's very important about this is since this is an open forum, you will get the chance to ask questions. So that's one thing that we encourage you to do. Participate and ask your questions live. Kasi kung yung estudyante gusto niyo tanungin, paano ka ba makaka-perfect ng exam? How do you prepare for the board exam? Mahirap ba ang PhD? Yung mga bagay na yan po, bibigyan namin yan ng sagot sa inyo through this event. So we highly encourage for you to register to this event kasi ito pong mga gantong personalidad na ganto katatagumpay, medyo mahirap po silang makuhanan ng oras and we're very fortunate na pag-uukulan po tayo ng panahon ni Crisita Carmen Atienza. Siya po talaga ay, we believe like a figure that everyone in the STEM community, lalo pa yung mga kabataan, dapat yung makilala yung mga successful Filipinos like her. So we invite you to this event. Yun po. And we hope to see you again like next week on Saturday. Okay, back to you, Marty.
All right, yeah. Thank you, Kuya Jeff, for that announcement. So, stay tuned lang po. Medyo marami po talagang line up na topics and webinars for the next few months. And also, Kuya Jeff, parang hindi mo nabanggit yung Lions din.
Ay, oo. Siguro after nung Q&A.
Okay, sige. So, it's almost lunchtime po, so you can freely grab your lunch while we're finishing the question and answer. So yung raffle po, after ng question and answer po natin i-announce kung sino po yung nanalo. So live din po yung pag-draw ng raffle para po wala pong question about the raffle. So Ma'am Dindi, are you still there?
Yeah, and Marty, just clarify, hindi po kami nagpapabayad sa raffle, giveaway lang po to. So may nagtanong po kasi kanina, wala po kayong kailangang ibayad sa amin. So yun po, participate live, fill out the Google form. Marty, yeah.
All right. So may mag-ask daw po ng live si Sir Melvin Rabulan. If you can unmute yourself po. Sir Melvin, are you still there? Okay, so while waiting for Sir Melvin, siguro ask ko muna yung ibang question from Zoom and Facebook. I mean from YouTube. From
Hello,
Henry. Ayun, nandiyan na siya. Sige, go ahead po.
Just out of curiosity, I'm just wondering if it's all right to categorize organic compounds that all biodegradable can be considered organic, while non-biodegradable as inorganic.
Ma'am Dindi,
Sige, go ahead, Jeff. Go ahead, Jeff.
Okay, so yung kasing biodegradability, hindi talaga siya marka. Kasi there are polymers, for example, biopolymers, nakukuha niyo sa mga halaman. May mga components po yan na hindi niyo mabibreakdown ng mabilis. So it will take thousands of years sometimes bago niyo siya ma-decompose. So if your definition of biodegradability is for something, for a solid, or for a material to get converted to carbon dioxide eventually, hindi pwedeng categorization yun na porke organic biodegradable siya. And the same goes through. The same holds true for there are certain inorganic materials na kaya siyang i-metabolize ng mga organisms to break down into much simpler components. So that's one thing po that we would like to address. Hindi porke organic ay na siya biodegradable po. So it depends po kung if they will break down quite naturally. So wag po natin siyang gamitin na parang sweeping or umbrella term for that. So hindi siya applicable in all cases.
All right. Ma'am Dindi, would you like to add something or that's good enough?
No, that's good. I mean, so nakita naman natin na yung polyethylene is an organic molecule. So that one doesn't it's not biodegradable. So yeah, it's not a good generalization to have.
Yeah. Sir Melvin, do you have follow-up question?
Wala na po, sir.
Okay.
Parang it's a misconception pala before.
Yeah.
I see.
Okay.
Thank you, sir.
Yeah.
Okay. From Henry Giel, will the structural arrangements, say, for example, of propane and cyclopropane, have an effect on their inherent properties po? Thank you very much.
Yes, tayo dyan, ano? Yes. Well, so cyclopropane is really it's an unstable molecule. So very reactive yan, very unstable in the atmosphere. And yeah, I mentioned earlier na different arrangement, different structure means different properties. So
Siguro, yeah. Siguro yung mabibigay ko sa inyo na pinaka-realistic na, pinaka-relatable na example po is, for example, yung saturated nyo na plant oils versus unsaturated. Yung po kasing saturated, nakita nyo linear lang siya. So if you imagine linear molecules po, they will stack up quite efficiently kasi pwede nyo siyang patasin in an organized manner. At kapag po organize yung stacking ng inyong molecules, typically po yung kanilang melting point po ay mas yung hindi sila nagso-solidify more easily. So they would actually they would solidify more easily kasi they stack up parang nag-form sila ng solid matrix. So yung saturated fat, kaya hindi natin yan gusto kasi po sa katawan nyo magde-deposit siya kasi yung melting point niya mababa. So madali siyang maging solid. Pero pagdating po nung unsaturated fat ninyo, so you have your trans isomers po. Hindi sila magpapatas-patas ng maayos. Therefore, hindi sila mag-form ng solid. Hindi sila madaling mag-deposit sa inyong katawan as parang plaque. So ganun yung siya i-imagine. So bakit ang butter ay solid at room temperature? Bakit ang mantika? Bakit yung vegetable oil ay hindi? So yun po, yun ay nakadepende sa kung ano ba yung mga functional group, yung difference sa structure. Kapag may double bond ka, iba yung property niyan. Kapag linear yung molecule, iba rin yung property niyan.
All right. Thank you po for that answer. So I'll give the next question. Ito po nakakatuwa kasi bata pa siya kung sa time natin parang first year high school yung nagtanong. So from a grade 7 student, what organic bonds can be found in our body and in other stuff? So this is a question for Ma'am Dindi. So nakakatuwa kasi this is a valid question from very young future scientist, hopefully.
So, ang tanong is, ano yung functional groups?
What type of, yes, baka po functional groups or types of bonds, yes.
Oh, or types of bonds. Okay, so magsimula tayo sa DNA siguro, no? Yan ang familiar sa atin. So, DNA is ang structure niya is due to hydrogen bonds present in helices. So, meron kang 2 helices. Pero yung pinaka-backbone mo is nucleotides. I think I showed the structure, no, for nucleoside naman. Pero ang nucleotide kasi is meron ka lang phosphate dun sa sa sugar ring mo, di ba? Si Sir Jeff na napapaisip. So, sa structure ng DNA, meron kang hydrogen bonding, pero ang functional groups doon, nakita natin sa slides kanina, meron kang alcohols. Let me go back to my slide. Teka lang.
Actually, yung tanong ba, Marty, is yung mga functional groups na meron sa katawan?
Yes, and types of bonds. Siguro, yun na rin yan. Functional groups in general or double bonds, triple bonds.
Ayan, I mean,
halos lahat yan.
Halos lahat. Oo.
Actually, let's say, for example, all the amino acids represented na lahat ng functional groups actually sa amino acids. Kung makita mo, may amide, may thiols, may disulfide bonds, may phenols, di ba? Parang lahat nga represented.
Oo, lahat na actually. Totoo yan, lahat na.
So nakakita yun sa katawan natin, halos lahat ng functional groups na na-discuss kanina ni Ma'am Dindi.
Oo, lahat yan meron, para sa mga bata na nanonood, no? Lahat ng functional groups na pinakita ni Professor Dindi, makikita nyo yan sa biological organisms.
Pero that's a very good question coming from grade 7 ba?
Yeah.
Grade 7 po, yes. First year high school nung time natin.
Basta iisipin nyo, lahat ng processes kung paano tayo humihinga, paano tayo nagda-digest, lahat ng biological processes, these all involve organic transformations. So yung structures po ng mga compounds diyan nagpapabalik-balik lang yan in the form in different biological cycles. So actually yung gusto ko i-share sa inyo na I got reminded by my organic chemistry experience back in LB po. So nung naintindihan ko na yung organic chemistry, madali kong maintindihan yung biochemistry. At pagdating doon sa biochemistry, maintindihan mo paano kaya nagkakaroon ng sakit on a molecular level. Ano yung chemical reactions, bakit nagkakasakit ang tao, paano gumagana ang gamot. Yun po, yan yung mga mahahalagang bagay na matututunan nyo if you have a fairly decent understanding of organic chemistry. So sana po makita rin ng ating mga guro na yung pong mga organic compounds na tinuturo natin, hindi lang po siya for demonstration purposes na itong ethane, itong ethanol, itong isopropanol, itong acetone. Lahat po yan may mga real life applications po yung mga itinuturo po sa inyo. At mahalaga po ang role ninyo sa high school level na ma-establish yung comfort level ng mga estudyante sa organic chemistry para po mas madali sila talaga, mas ma-appreciate nila yung mga bagay na to.
All right. Thank you, Kuya Jeff. Ma'am Dindi, this is an interesting question. You discussed earlier daw po na yung carbon dioxide and carbon monoxide are not considered organic. So tinatanong po niya, bakit daw po hindi siya considered as organic compounds?
So, ang original definition kasi nga ng organic chemistry, organic compound is those compounds present in or obtained from living things. Tapos, eventually, nag-evolve na lang yung definition because they found out na you can actually produce organic compounds from inorganic raw materials. Pero yung division between organic and inorganic stay the same. Pag hindi siya galing sa living, if it's not produced from living organism or living thing, then it's not considered organic. And one characteristic nga, yun, very distinct characteristic ng organic compound ay meron siyang at least one, most of them contain at least one carbon-hydrogen bond. So yun lagi yung dapat tinitignan, dapat at least one carbon-hydrogen.
Okay, so yun po, mahalaga yung sinabi ni Professor Dindi, wag niyo, para hindi kayo ma-confuse, mayroong isang at least one carbon-hydrogen bond. Yun po, yun yung main requirement para sa definition natin ng organic compounds po, no. So at least sa sa what we call this sa high school level, kasi syempre may mga exceptions yung mga bagay na yan, kasi when you have halocarbons na yung hydrogens yun napapalitan lahat po ng for example fluorine, napapalitan niya yung hydrogen, organic compounds pa rin po yan. But at the high school level po, for your basic appreciation, at least kung kung yung operational definition muna natin, meron at least one carbon hydrogen bond. But for more complex examples, yan po may encounter nyo na yan sa college level.
And meron, yun nga, yung expertise ni Dr. Jeff, organometallics, ano? So meron.
May metal din yan.
Yun. But it's still considered organic, so.
Yeah. So, pero ngayon po, yung accepted for now po na yung carbon monoxide and carbon dioxide, since wala silang carbon hydrogen bond, they fall in the category of non-organic molecules or species po. So, yun muna. Yung one carbon hydrogen bond. That's the minimum.
Yep.
All right. So another question from Clinton Imbong. Are all polycyclic aromatic hydrocarbons generally considered carcinogenic?
I think so. Parang naalala ko to sa environmental chem. There's actually a linkage.
So ito 161 natin sa biochem from UPLB, no. Ito yung common characteristic nun is po kasi siya, parang may mga aromatic rings kayo, it can intercalate sa DNA. So nagka-cause siya ng shift dun sa pairing ng inyong DNA base pair. So technically yung definition po, yung pagkakaturo sa amin nun are polyaromatic hydrocarbons. But then, syempre, hindi po natin siya i-generalize na lahat yan, no? Pare-parehas ng effect. Kasi meron po dyan sa classification na yan na siguro nagkukos talaga ng mutation. Baka naman merong ibang hindi. Pero valid yung question. Merong parang general concept na those classes of materials may cause cancer. So parang gano'n po. Kaya these molecules are monitored rin as when it comes to environmental chemistry. So actually si Professor Dindi, she worked for an environmental monitoring company at one point. So ayun po. Good question.
Ayan. So Ma'am Dindi, may question po dun sa follow-up question. Yung HCN daw po, considered daw po ba siyang organic kasi may one CH bond?
Okay. So, well, okay. So, medyo nandiyo-challenge yung ating mga no? I mean, technically.
Yes, by our definition. Pero,
okay, by our definition, you can consider it organic, no? Kasi, di ba, you have a carbon-hydrogen bond right there. So, dun kung sa operational definition na binigyan namin, you can consider it organic rin. But then, pero kung gusto niyo po talaga ng malalim na definition, papasok tayo talaga dun sa nature ng mga bonds doon. So, ano ba yung nature ng carbon-hydrogen bond doon? Gaano ba covalent yun? Bakit kakaiba yung property ng HCN in comparison to other cyanides?
So actually, HCN is hydrocyanic acid.
Hydrocyanic acid.
It's actually the bond, the CH bond there is actually not a covalent bond because
not purely
kasi Yeah, especially if you in aqueous environment, diba?
It
It
dissociates.
becomes an acid, nagdi-dissociate yan. So it's not a pure covalent compound. So yeah, medyo tricky nga po yung definition.
Nasa gray area. Nasa
gray area.
Pero dun sa definition natin now, at least may carbon-hydrogen bond, di pa, pwede po
pasok siya.
Pasok siya dun. Pero in terms of properties po, it doesn't behave like your regular, say, organocyanide compound. So,
kasi acid siya.
Sino yung nagtatanong na yan? Medyo nancha-challenge siya. Taga-saan ba yan?
Matatalino ang ating participant.
These are very good questions. So actually, medyo maganda yung mga questions.
Magagaling talaga.
At ito po, yung gusto ko rin po sabihin sa inyo, kasi may mga sinabi kami about structures, ganyan, ganito nyo dapat i-imagine yan. Yung isa pong mahalaga yung dapat tatandaan, when it comes to chemistry, karamihan po ng mga concepts natin, those that are relating to structures, charges, yung mga ganyan po, may mga -1, -2. Most of these things are based on formalisms po, no? So when we say formalisms, these are accepted standard ways by which we imagine or we visualize chemical species po for the purpose of simplification. Pero kung ang pag-uusapan po talaga natin ay yung real nature ng molecules, ng electrons, ng bonds, ay papasok po tayo dun sa medyo nakakalitong konsepto ng quantum chemistry. So doon na po, kung gusto niyo po talagang pag-usapan natin yung properties ng hydrocyanic acid, what makes it partially covalent and what makes it partially ionic, kailangan po nating mga maging Sheldon Cooper po, yung kailangan po natin dyan ng quantum mechanics. Yes. So dyan na po talaga, kung meron po talagang matapang sa inyo, i-message nyo po kami. Si Dindi po, nauna po ni Dindi yung subject na yun ng quantum chemistry sa UPL.
Chem 115.
Opo, Schrodinger's equation, lahat po na yan. If you would like to engage, and these are very good kinds of discussions.
Yes.
So if you need very good questions, if you have questions about more advanced chemistry topics, feel free to message us po, and we would be glad to entertain those questions.
Tsaka these are very challenging questions that china-challenge talaga yung definition natin. So this is very good question from our audience.
Na-appreciate namin yung tanong. Very good.
Just a follow.
Yeah.
Just a follow-up on that kasi meron ding nagtanong actually, I'm just wondering, do all organic compounds have a covalent bond? So isa ba siyang qualification to be considered as as an organic compound? So bukod sa CH, baka yun pa yung isang qualifier, dapat purely covalent bond. Would you say so?
Papasok na naman tayo dyan sa medyo kasi sa totoo, I mean, ito po, speaking as a scientist po, as a highly trained chemist, wala naman po kasi talagang bond na purely covalent. So by all, yung main definition po talaga natin dyan. But yung main requirement po is you need to have at least sa high school po definition, you need to have at least one carbon-hydrogen bond. And you can only form a carbon-hydrogen bond if it's a covalent bond.
Covalent bond, exactly.
So yun yung, so technically dapat meron.
Tama.
Dapat meron covalent bond.
All right. So this will more relate to biochem, from organic to biochemistry. Thank you, Dr. Dindi. This session is very informative and inspiring, from Christine Manaloto. Just wanted to confirm if enzymes causes conformational change in the structure of a certain compound. And nauubusan ba tayo ng enzyme sa body, or do we consistently have that?
That's a very good question.
Confirm if enzymes causes conformational change in the structure of a certain compound. So, ang enzyme kasi, you have certain active sites that fits your certain compounds in the body. So, actually, ang nag-a-adjust dyan yung enzyme to quite fit into you. Pero meron kasing dalawang mechanism for enzymatic reactions. So, actually, this is a biochemistry question. So, I might
if I may also interject, no. So, kasi medyo leading kasi yung question if enzymes cause changes in the conformation. Medyo hindi kasi siya pwedeng sagutin that way.
Sagutin yan.
Okay, so if you could imagine an enzyme po, an enzyme has a pocket which we call an active site.
Active site.
And depende yan sa enzyme. May mga enzymes po, may mga enzymes po like that could accommodate a certain structure within that pocket. So, kumbaga dapat po may compatibility yan in terms of structure. So, it's not necessary that it's always including a change in conformation. Pero ano po siya it's more than a conformational structure. Kasi ito po the binding between an enzyme active site and a molecule that is activating, it depends on a number of things. So yung bang tamang functional groups nandun ba sa molecule that's binding? Kasi hindi siya didikit kapag wala siya yung favorable interactions for an enzyme and a molecule binding. So that's one thing. Conformation is also a very important aspect. So if your molecule can change its conformation to fit in the pocket, in the active site, then that could lead to an interaction. Diyan po papasok yung ating mga what we call that inhibitors. So yung mga molecules na medyo kaparehas ng properties, size and polarity, for example, na kaya din competitively unahan yung molecule dapat na ma-activate. Those are things to consider. So wala po talagang parang one specific answer like to that. Possibly po by means of intermolecular forces of attraction, some enzyme active sites could induce conformational changes. I don't think that's impossible, but hindi po siya ganun hindi lang po yung enzyme yung magde-dictate nun. There's a bunch of different factors po. And actually,
yes.
In all honesty po, sa biological systems, bago pa po makarating sa active site ng enzyme yung inyong molecule, yung pong packet, yung pong column, yung pong chemical environment na pagdadaanan nun, marami din po yung mga functional groups. So even before it reaches your active site, tumatumbling-tumbling po yung molecule nyo. So ganun po siya. So,
oo, we cannot, parang hindi natin ma-generalize kung meron talagang conformation. But maybe meron talaga. Pero ang sure tayo yung mga isomerism na enzymes, meron talaga nun. Pero itong conformational, parang yun nga sabi ni Ma'am Dindi tsaka ni Kuya Jeff, minsan nag-a-adjust talaga siya dun sa, before pa siya pumasok dun sa active site, nakakapag-adjust na siya based dun sa gusto nung active site, di ba?
And you know what's good about enzymes po? Kasi enzymes, they had millions of years to perfect their function. So kami po mga scientists, I'm a catalysis expert. I make inorganic catalysts, for example. Kasi ba enzymes are catalysts as well. But then yung kaya namin pong i-develop in 1, 2, 3, 4, 5, 10 years, that's nothing. Hindi po namin kaya talagang higitan hindi po namin kayang higitan yung kung gaano ka elegante yung design ng enzymes kasi it evolved over lahat po ng pagdadaanan ng inyong molecule para makapunta sa enzyme, may function po yung mga yan. And it took millions of years for enzymes and biological systems to perfect their function. So I'm sorry po kung hindi namin kayo mabigyan ng specific answer kasi this would have been like much easier if we're talking about a specific system na nakikita namin yung structure. But that is not to say na wala. That's also not to say na all enzymes can do that.
All right. So, medyo challenging ang mga questions today. Kasi nagba-branch out na agad sa biochemistry. So, watch out for the introduction for biochemistry. Kung sino man ang matatap natin. So, there are still some questions. Siguro we'll entertain 2 more questions before we wrap up. So, ito po ay from John Alvin Rabulan. Does the type of bond affect the skeletal structure? How about the name of the compounds? Itong types of bonds naman siguro mga single bond, double bond.
So, if it affects the skeletal structure?
If it affects the skeletal structure. And how about the name of the compounds?
Yeah, it does. So, nakita natin sa slide na if you have a double bond, of course, you have to add that to your skeletal structure. Mag-add ka lang ng isang line on top of the skeletal structure. And the other question was the name. Yeah, it will. Yeah, it will affect the name, of course, depending on the type of functional groups. So, hindi natin diniscuss yung naming ng ibang functional groups kasi aabot yata tayo ng I don't know, isang buwan. It's a long system, ano.
But we will have
Yung
follow-up
basic-
sessions po. We will have follow-up sessions to
Oo.
discuss the other functional groups. So that's the good
Oo.
thing about your Professor
So,
Dindi.
oo.
Yeah, agreeing to do this for all of you po. So, meron itong mga follow-up lectures. But then
Yeah. But good question. Good question.
Good question. Definitely sa skeletal structure may effect kasi nakita nyo kanina yung alkanes, 'di ba parang ganun-ganun siya. Hindi siya flat. Hindi katulad ng alkenes, flat siya. So kahit magkaiba sila ng functional group, magkaiba ng types of bonding pero magkaiba yung skeletal structure. All right. So one more question, ito super advanced. From Antoinette Frank. Hi po, I'm taking my advanced organic chemistry now. Pero sabi po ng teacher namin, mas maganda daw gumamit ng mechanistic approach when you teach organic chemistry. My question is, can you provide us with the simplest pattern ng learning organic chemistry by mechanistic approach?
Okay, ako yung watch out. We just do so over the next couple of months we might not be able to do that, but yan, I can deliver that myself. If you want hardcore mechanistic chemistry approach, and that's important kasi kapag alam mo yung reaction mechanism, ang reaction mechanism po is kung paano po ba gumagalaw yung electron across a particular molecule para mag-undergo ng chemical reaction. At kapag po yung understanding nyo kung paano ba natatransfer or nasi-share yung electrons during chemical reactions, madali na lahat ng bagay. Kahit anong reaction yung ipakita sa inyo, alam nyo na aling functional group ang mag-react with the functional group of the other molecule. Alam nyo kung anong product, alam nyo kung ano yung mga side products if possible. And then at the same time, when it comes to biochemistry, so doon po ang dami-dami ng chemical pathways dyan. Yung iba, tingin nila they just have to memorize it. But you don't have to memorize a specific reaction if you have a good understanding of the concepts of polarity, the concepts of electron movements. Yun po. So yun, pwede po namin i-deliver yan sa inyo. We just cannot promise a specific date as of yet. But there are some very good books out there. Kami sa UPLB, our textbook back then was McMurray. Yun yung inaaral namin doon. And the good thing about that is marami siyang examples and mechanism based siya. So ako at the moment, since wala pa kaming lecture for that, I would suggest that you guys check out some of those chemistry textbooks kasi medyo student friendly yung pagkaka-present doon ng mechanistic aspects of chemistry. But if there's one thing, if you want to learn mechanistic organic chemistry, dapat yung proficiency mo sa Lewis structures ay mataas. Kasi kapag pamali-mali ka na pagsusulat ng Lewis structures, there's no point learning mechanistic chemistry because you have to figure out what would be the electrons involved in the chemical reaction. If you cannot write or if you cannot draw Lewis structures quite well, then your mechanisms will be wrong. And then secondly, the concept of polarity. Actually, sa totoo lang po, if you can master the concept of bond polarity, madali lang po ang organic chemistry. Hindi po talaga siya mahirap. It's there's a lot of patterns that you can recognize from all of these reactions. Basta yung konsepto ng structure ay tama at yung inyo pong appreciation of bond polarity ay mataas din. Kapag if you have those foundation skills and knowledge, kaya nyong iuno yung organic chemistry sa college.
Ma'am Dindi, do you want to add something?
So I think yung nagtanong gusto niya ng simplest pattern for for the mechanistic approach. Parang nasabi na lahat ni Jeff, but I don't know if there's any more simpler than that.
Hindi kasi siya masasagot ng a couple of sentences. We can only explain this via example.
Exactly.
Kasi yung concept ng Lewis structure, yung concept ng resonance structures, yung mga ganong konsepto kailangan mong naiintindihan bago maituro sa iyo yung reaction mechanism. And actually, magandang point yan. Sa halip na i-memorize nyo, kapag mo memorize nyo lang yung reaction equation sa organic chemistry,
makakalimutan mo kagad.
Hindi siya, that's yung concept of learning things by heart. If you know things mechanistically, you learn it by heart. So kahit anong molecule yung ipakita sa'yo, kahit sobrang laking molecule, alam mo kung alin lang doon yung magre-react. kung alin lang doon yung magbabago. And yeah, thanks for bringing this up. So hopefully kapag medyo na free up na yung schedule ko, siguro sometime in June, I can schedule a session po. Ako mismo yung magle-lecture niyan. Yan yung sobrang enjoy ko when I took up chemistry. So hindi ako nahirapan sa organic chemistry and biochemistry because mechanistic yung approach. That was what my UP the research thesis advisor taught us, na dapat mechanistic yung approach para no need to memorize. Yun po. Hindi mo pahihirapan yung utak mo. But alam mo lang yung ano yung patterns. Yun po.
Yan, tama si Ma'am Dindi tsaka si Jeff. May certain patterns ka lang na dapat sundan, and tama yung mga basic concepts na dapat mong malaman. So, lahat po ng chemistry graduates, I think, napagdaanan po nila ito. So, for the teachers po na nagtuturo ng chemistry, if you want to be above your students with respect to reactions, you should also try to study mechanistic organic chemistry. Kasi po, dyan po, kahit anong compounds ang ibato sa inyo or reactions, masasagot nyo po. Even if hindi kayo, kunwari, hindi po nyo memorize functional groups, pero alam nyo po mag-arrow pushing, masasagot nyo po yan. So, I encourage yung mga high school teachers po natin ng chemistry to also find the extra mile para maintindihan din po yung ganong types of concepts. Kasi medyo, kailangan po medyo angat tayo ng konti sa mga estudyante natin. So, in terms of that competency, talagang yung understanding natin ng chemistry will be very good.
Okay. And then watch out for it po. Actually, yung gagawin kong lecture, siguro gawin na lang natin siguro ng May. Watch out for an announcement po. Yung ituturo ko about basics of reaction mechanism, para sa mga teachers, para alam nyo kung ano yung mga dapat ituro nyo at the high school level. So yun po, watch out for that. Medyo masama po kasi talaga akong hinahamon. Pumapatol po ako sa ganyan.
Ayan. Eto na, last na talaga kasi follow-up question lang to dun sa enzymes. Tinatanong kasi niya kung nauubos daw ba yung alcohol dehydrogenase. Siguro manginginom to.
Okay. Si Janice, where's Janice? I think this is in your area. I have no idea. Hindi ko alam yan.
Si Janice in your area.
Janice po is a scientist po who studied that, right?
Pinatut ko na siya. Actually, minessage ko siya privately. Kasi yung tanong niya ay kung nauubos nga daw yung alcohol dehydrogenase. Kasi itong alcohol dehydrogenase, it's one of the two enzymes na gamit ng katawan natin to metabolize alcohol. I don't think na nauubos siya kasi yung body natin is naturally they produce these enzymes. Pero merong certain, what do you call this?
Demographic. Meron certain demographic na wala.
Pero may certain mutation kasi sa body natin na yung ibang tao nagkakaroon ng
hindi nagpo-produce.
Deficiency, hindi.
So Janice, di ba Janice, in general, Asians mababa yung alcohol?
Oo. Kaya di ba yung Asian flush, it's because we have hindi tayo kasing dami mag-produce compared sa yung mga Western hindi .
Yung sinasabi po ni Janice na Asian flush, karamihan po sa ating mga Asyano, pag uminom po tayo ng alak, namumula agad kayo. Kahit isang sip lang. Yung iba po mabilis parang malasing, di ba Janice? Parang ganun siya. Kasi
hindi mabilis malasing, pero parang dahil nagdadilate ang ating mga blood vessels, so namumula tayo. Ganun siya. So in deficiency lang siya, ibig sabihin kulang, hindi tayo kasing dami mag-produce.
Kumpara sa ibang lahi. So yun po, trivia from Janice. Yun po.
Kaya mistisahin.
Your PhD was on alcohol dehydrogenase, yung PhD research mo?
Hindi.
Yung postdoc niya.
Bagong salta lang din ako sa medical field kasi yun. Ang study namin is on
liver.
Alcoholic liver diseases. So yun. Ang lang namin is parang although hindi naman proven, pero parang medyo mas mag-ingat tayo sa kakainom kasi dahil nga may deficiency tayo para sa pag-metabolize ng alcohol. It could be possible na may diseases na nagkukos siya. Hindi naman proven, pero yan. Kaya wag tayo inom ng sobra. Ako pag namumula na ako, I stop.
Tumigil na. Ayun.
Ibig
Martin-
sabihin hindi na kayang i-metabolize ng system mo yung alcohol kaya ka nagkakaroon ng reaction.
Nag-accumulate na siya sa katawan. So, may tanong dito, ano daw ba yung recommended book for teaching organic chemistry? McMurray po kasi yung sa college level na na-experience namin doon. So, actually medyo mahal lang po siya. Diba,
McMurray.
Pero kung for high school students, there's a book called Frost and Deal, Introduction to Organic Chemistry. So very very introductory lang din siya. Kung for high school teaching.
Apo, yung thesis advisor ko nung college po, sa UP, she wrote an Introduction to Organic Chemistry. That's by
yung kay Ma'am EBR.
That's by Evelyn Rodriguez from UP Open University po. So yun, magtingin po kayo sa bookstores kasi meron pong ganun, napaka-friendly.
Baka pwede sila mag-request sa OU.
Yeah, baka
ng copy.
Ng copy sa Open University kasi yun po. At yung pong thesis advisor ko po mismo na organic chemist, siya po yung nagsulat. No?
Maganda yun. Kasi may work, na agad yun, may activity sheet na.
Yeah.
Meron ako, nasa akin ata yung libro mong ganun, Kuya Jeff.
Ay, nasa iyo ba?
Nasa akin ata.
Kaya siguro galing mo.
Nagkabulgaran ka na hindi nagsusulit.
Oo, maganda nga yung libro na yun po. Pero katulad nung sinabi ni Ma'am Dindi, meron din yung McMurray na Introductory to Organic Chemistry. Hindi siya yung pang majors. Medyo manipis lang din. Pero meron ding talagang pang majors na McMurray. Pero yung ginamit ko talaga before is Morrison and Boyd. Hindi ko alam kung bakit yun yung mas naiintindihan ko kumpara kay McMurray. Ang dami po talagang libro. Depende sa level ng gusto mong pagkakaintindi.
Ito po yung tip namin sa mga teachers at students, no. Kung medyo nahihirapan po talaga kayo sa organic chemistry, ang isang linya lang po, practice is key. So, pag nakuha niyo yung concepts, maghanap po kayo ng maraming libro, marami pong resources online na pwede po kayong mag-access ng quizzes. Practice lang po kayo ng practice kasi ang organic chemistry, it's a lot of pattern recognition. Yun lang po yun. Hindi nyo po talaga kailangan mag-memorize. Kung paano po ako nag-prepare, for example, sa organic chemistry exams ko noon. So, wala po akong masyadong textbook noon. So, pumupunta ako sa library, nagsasagot ako ng lahat ng end-chapter problems para maano po talagang tumatak sa memory ako. Ano ba yung mga patterns? May pattern po yan lahat. And then, online, para mag-prepare sa exam, magsasagot ako ng exams from MIT, from Cornell. So, pag nasasagutan mo nyo na yan, ibig sabihin nun, handang-handa na po kayo. So, kailangan po talaga magpa-practice kayo. Nakamute ka, Marty.
Alright, so that concludes our Q&A. So, meron ba tayong announcements, Kuya Jeff, or natapos na natin?
Ay, siguro yung Lions din. Lions din lang.
Ayun. So, sige. And I'll set up yung raffle po.
Sige. Okay, so let me just talk about our Lions then. If you can just give me a minute because I need to I'm still trying to find the person.
Gusto mo ako muna? Magpa-raffle na ako.
Yeah.
Okay, so we will do the raffle. So, meron po tayong 345 respondents. So, i-close ko na po yung Google form to 345. So, I'll share my screen. So, ayan. Nakikita mo na ba, Kuya Jeff?
Yeah.
Okay, so yung pong random generator na to, may mga numbers po kasi yan dito sa ating system. So kung ano po yung mapiling number, yun na lang po yung mananalo. So ito na po yung first na mananalo ng kit. So number 105. So 105, I see Rose Valerie Sanchez, college student.
Highlight mo na.
Okay, na-highlight na natin. Saan ba yung highlight dito? I-bold ko na lang. Hindi ko makita yung highlight. So, paki-contact na lang po kami sa Facebook namin kung para po ma-claim yung prize. And the second one is 239. Si George Yao from DepEd. Ayan. Congratulations po sa mga nanalo. Paki-contact na lang po kami sa Facebook page namin para po maklaim yung prize niyo. Okay, Kuya Jeff, are you ready?
Alright. So ito pa, very quickly before po tayo magtapos, gusto ko lang pong i-promote sa inyo yung aming event for high school teachers and students who are venturing into science investigatory projects. So this is what we call FilSciHub's Lions Den. So this is the Battle of Science Investigatory Project Ideas. So yung pong program namin sa FilSciHub Research University, we're providing you with training courses kung paano ba mag-initiate ng isang science investigatory project all the way up to data processing and research presentation. But then for us to be able to practice po yung pag-initiate ng project, pag-generate ng idea, we came up with this competition. So essentially, the process entails, okay, I think this is animated. So the process or the program invites teams. So yun po, kung meron kayong research project idea, form a team and then write up a research proposal and then isasubmit nyo po yun sa amin, and then we will try to select the 12 most promising ideas. And then what we'll do is that our team of mentors will help you develop that idea over a span of a couple of months. And then this process will culminate, at a stage where you will present it to an esteemed panel of Filipino researchers, which we call the Lion. So kailangan siyang i-defend yung idea niyo. You have to convince them that your idea is the idea that's worth 10,000 pesos, which is going to be the cash prize. So ito po yung mechanism dyan. So we encourage teams to be formed, so composed of 3 students and 1 teacher. What you have to do as a team is come up with a science investigatory project idea and then submit your research proposal in the preliminary round. So yung format po ng research proposal nandun po sa aming website, and we also have a YouTube video training on when it comes to idea generation and research proposal writing. So check our website out po para makita niyo yung format na naka-upload na po yun doon. So we are accepting applications from all over the Philippines, so Luzon, Visayas, Mindanao, and the National Capital Region. And so out of each region po, 3 finalists yung pipiliin. 3 from Luzon, 3 from Visayas, 3 from Mindanao, and 3 from NCRs. And then yun pong mga finalists na yun, we do have a panel of mentors na i-assign po sa inyo. So dun po, nakakakuha kayo ng first-hand experience kung paano ba na ma-mentor ng Filipino scientists po from the panel that we have. And then after that po, those semi-finalists will proceed to the final round, which is the battle of the research pitch. So we also have a training course on how to pitch your research idea. So panoorin niyo po yan dun sa aming YouTube channel, and so we do have a training program on this. So you will pitch your idea in front of our Lion. So ito po, dito na kailangan maganda talaga yung idea nyo para lumusot siya, kasi sobrang gagaling po ng ating mga judging panel dun sa last round. So but we will help you prepare for that. So ito pong lahat ng mechanics na to ay nasa ating website, as we said. Yung pong criteria for judging, 40% sa proposal quality. So napaka-importante po na first step. And then yung Lion score. So kapag dinefend nyo na yung idea nyo, that will comprise 60% of your final score. And ito po yung prizes. So yung grand prize, we're giving out 10,000 pesos to the team with the best idea. Yun po yung mahalaga yung pwede niyo po siyang gamitin as funding for your science and for your science research at the high school level. Yun po. And then aside from that po, meron po tayong 3 Lions, and we will also be picking 3 Lions choice. So each of them will also receive 5,000 pesos po that you can use as research funding. So as early as now, we're encouraging you to participate in this. And yung deadline for submitting your proposal is actually on April 30. So you still have about 2 months to come up with a proposal. And if you have questions po about the proposal, about the mechanics, feel free to reach out to us. Yun po yung gusto namin sabihin. And then key dates, deadline ng proposal is April 30. We will announce the semifinalists on May 30th. And then you will have a month to prepare for the presentation. So dito po, yung mentors po ninyo ay bibigyan kayo ng 1 or 2 hours of mentorship time. So bibigyan nila kayo ng feedback kung paano ba ma-improve ang inyong idea, the best way to present your idea to the Lions. And then so on July 2nd and 3rd, we will be shooting yung Lions din. So yun po, haharapin nyo na po yung ating judging panel that is composed of 3 internationally recognized Filipino scientists from different areas of science. So yun po, papakilala ko lang po ang ating pong mentor. So Dindi Yu will handle all the Luzon entries. Marty Mateo will handle all the Visayas entries. JP Onya, Mindanao entries. And then Ralph Lauren Alomia and Janice Avrila will handle all the NCR entries. So sila po, pag napili yung entries nyo as semi-finalists, sila po mismo i-mentor po kayo. So yun po yung magandang makukuha nyo from this experience. And then from all those po na magsasubmit naman ng entries, we will try to provide feedback po even if you don't reach the semi-final round. And then yung mentors po natin, papakilala ko lang po. So sila po yung mga scientists na mentors natin. So the first of which is Filipina Scientist and Professor at UP po, Professor Joan Aguila. So she's an expert in organometallic chemistry. Siya po ay meron pong research group ngayon sa UPLB. So she's doing research when it comes to biomass and environmental remediation. So siya po, teacher ko siya sa inorganic chemistry. So she's really, really good. Yung pangalawa naman po nating Lion, judge sa final round is Dr. Let Carrasco. So she is a seasoned Filipina scientist in the area of industrial chemistry. So yung kanya naman pong experience is based here and abroad. So she's in the US, she's actually been working in the oil and gas service sector. So iba naman yung experience niya, may manufacturing experience siya, engineering. So iba naman po yung perspective na idadalhin niya sa table. And then last but not the least is Chester Dabalos. So Chester Dabalos is actually one of the smartest people I've ever come across with. So idol po natin yan. So he did this master's in Cambridge University, which is actually one of the top 10 universities in the world. He did his PhD at the University of Hawaii in Manoa, and then he's essentially lahat po ng areas, biology, physics, and chemistry, lahat po yan halos inaral niya na. So he's a very wise, he's actually one of the most passionate STEM intellectuals that I've ever come across with, and para po ma-experience na natin mga estudyante sa Lions, then I think it's a very good opportunity po for you to learn. So we invite you all po to participate sa Lions din. We're looking forward to receiving your entries, and as we said po, if you have questions, reach out to us po through our email account, FilSciHub@gmail.com, and also through our Facebook page. So yun po, maraming salamat. Maraming salamat po uli sa pagtuto kasi ano naman po na sana po hindi naman po kayo nainip sa mga bagay na aming ibinahagi sa inyo.
All right, so thank you Kuya Jeff. Kuya JP, did we post? Ay, ayan, nakita ko na. So the link for the certificates is already posted in the Zoom chat box and YouTube comment section. So please fill out the forms para po magkaroon kayo ng certificate. And don't forget to like and follow our Facebook page, that's Filipino Science Hub, and also our YouTube channel, FilSciHub, for you to get your certificates. And with that, we are ending this session. Again, we would like to thank our speaker, Dr. Dindi Yu Voils, for generously sharing her knowledge. Ma'am Dindi, are you still there? Can we give Ma'am
Yes,
Dindi a virtual clap?
Baka pwede tayo mag-picture with the Zoom participants at least para merong token for
All right. So kung pwede po daw nating i-on ang ating mga cameras for
class
ayan.
picture. Ayan.
Class picture, ayan.
Hello sa inyong lahat. So,
it's good to meet you all po.
Ayan. So medyo 5 beses po tayong ngingiti kasi 5 beses 5 windows. So okay, 1 2 3. Isa pa po. Full screen na. Okay. So 1 2 3. Next. Yeah. 1 2 3. All right. So yung iba po wala nang video. So 3 lang yung merong video.
Ayun, maraming
So,
salamat po.
maraming salamat po for joining us today. Thank you, Ma'am Dindi.
You're welcome.
See you next time. See you next time.
Okay, bye everyone. Take care.
See you next week.
Next
See you.
week. Ay, yung next week po na session talaga, don't miss it. Ano po, once in a lifetime experience yun. Para makapag-share po ng ganun. Sobrang...
Oo, bagong format po yun ng FilSciHub.
Opo. Ano siya. It's gonna be like a very fun session po. So see you all next week po. Saturday naman tayo, 11. Tanghalian po yun. So kumuha po kayo ng tanghalian para kumakain kayo habang nag-uusap-usap po kami. Maraming salamat
Alright.
po. Take care.
Thank you.
Salamat po.
Have a happy lunch.
Bye.